it's almost ready to go. You just have to on the stream remove the Can you turn on your camera? Yes. Because they changed the rule and now the cameras are all pointing.
Oh, the wrong direction. Oh, there we go. You have your background, but that's fine.
Yeah.
I think that's almost.
Hey, folks. Good morning again. We're going to get started here in about 5 minutes. 5 minutes and we'll get started. So find your seats if you'd like to. In about 5 minutes, we're going to get started with our first talk. Hey, welcome back. We're in room 1. This is the first talk of the day. Today, we're going to start the day off with Type 1 fun for Type 1 hypervisors. I'm happy to introduce Alex and James. They're going to give you a great overview of Type 1 fun with Type 1 hypervisors. Please help me welcome them. Good morning. Thank you so much.
Thank you. Thank you.
All right.
Hello, everyone. Welcome to Type 1 Fun with Type 1 hypervisors.
Oh, hello. All right. So who are we? I'm Alex Zinla, the CTO of Adera. We have a booth back there if you want to go and check us out, and you'll know who we are because we're all wearing these shirts that are sweary and loud.
Yes. And we have more back there, so please take some.
Yes.
And James Peterson, staff engineer at Adera, was our first engineering hire and have been all over the place with Adera, so doing various jobs. Yeah.
All right. So we're going to talk about the 3 types of fun. Does anyone have any clue what that means? Just out of the box. like one person. Two. All right. So we're going to talk about we're going to go in reverse order. So we're going to talk about type 3 fun. So this is basically a model for understanding the types of fun in your life. Everyone kind of roughly knows that fun is more of a spectrum than it is anything else. So type 3 fun is basically a way of talking about a type of fun that's not really any fun at all. It's not fun in retrospect. It's not fun to do. But it maybe makes a great story. I'm sure I have a lot of career things to fall into this category. There's many, I'm sure some people are probably thinking of things that make a good story, but probably weren't that fun at the time.
Yeah, we do an annual ice climbing trip in my family, and last year we had to wait for 2 days of rain before we went skiing into the backcountry, which I would not do again because it was rainy and wet and not a fun time, but it makes a good story.
Sounds dangerous. Not my kind of thing. And then you have type 2 fun. This is the type of fun where it's extremely painful to do. It's fun in retrospect. You know, you ever look back and you go like, oh, I think that was probably worth it. And you're ultimately glad that you did it. And I think this is a super funny one because I would say that quite a lot of things in life fall into this category. Going to the gym is a great example.
Yeah, that's a great example. For me, it was having kids. To my wife, that was probably type 3, but for me, it was a lot of late nights, a lot of tears, but fun in retrospect.
I wouldn't know anything about that. And then we have type 1 fun. This is the type of fun you want to have. It's really fun to do these things. You'll have fun thinking about it. You'll reminisce about it, and you'll want to go back for more and do it all again. Our example for this is going to be a type 1 hypervisor. So let's talk about type 1 hypervisors and what is a hypervisor. So you probably all have used virtual machines. Many of you probably lived in the era where only virtual machines were really a thing. But a hypervisor is all about turning one physical system into multiple independent systems. This is mostly done for security. It's also done for kind of resource management. And it really provides that kind of security boundary between things. Importantly, a lot of people use this stuff like if you're AWS or Amazon, for example, your goal is really to separate out and divide up the physical hardware that you have on the ground between multiple different people. But a hypervisor is also a spectrum, interestingly enough. Most people are probably thinking about KVM and those kinds of things, and we'll jump right into that. So there are two types of hypervisors. The one that everyone thinks about is a type 2 hypervisor. And a type 2 hypervisor is one that runs on the existing operating system. So whoever here has installed, I don't know, Ubuntu or some base operating system and then launched like libvirt or something like that. QEMU maybe. So this is what a type 2 hypervisor is. A type 2 hypervisor is all about virtualizing the devices in a single process. A process being something like QEMU, maybe you have multiple different processes on the single system, but ultimately you're virtualizing devices and providing those virtual devices to an emulated system. And the security is entirely dependent on the host system. So if you install a bare metal operating system on the physical hardware, that hypervisor that you run, like QEMU, if someone were to attack your host operating system, they could potentially access every single virtual machine that is running on that system. And that's a huge risk because ultimately people are running just standard operating systems. Think Red Hat, think Ubuntu, those kinds of things. They require continuous security updates. They have remote access. They have all these different risks associated with that. And technically, this is a little bit of nuance here. The hypervisor is actually not QEMU. It's not libvirt. The hypervisor in this case is actually KVM, which is built into the Linux kernel. It's a huge, important distinction. A lot of people kind of blur the lines. I get a lot of calls where people call QEMU a hypervisor. I'm not pedantic about it, but it is a very important distinction because ultimately 95% of what people are running virtual machines on is actually the same hypervisor, which is kind of sad, actually. So let's talk about what a type 1 hypervisor is. A type 1 hypervisor runs directly on the hardware. It's the very first thing that is actually running and managing the CPU and memory resources. Think like VMware. A virtual machine provides services to other virtual machines. So one very important distinction with the type 1 hypervisor is that the layer that's actually running as a software layer on the system, its only responsibility is to partition the system. It partitions CPU resources and it partitions memory resources, also devices and physical hardware. And the security is completely guaranteed by the hypervisor. Because that layer is much thinner, the security is like you don't have remote access, for example, directly into that hypervisor layer. You have a management layer that sits on top of that is actually in a virtual machine that is providing those resources. So, sounds kind of advanced, right? Sounds like a lot of work. Well, it is. It's a whole lot of work. And we spend a lot of effort thinking about things that you would never understand. This is my favorite meme. I saw this on, I think, Tech Talk or something, and I immediately identified with it. For those who can't read it, it says, "I'm dipping nuggets you've never heard of into sauces you could never understand." We deal with types of problems that no one really thinks about, no one really knows are there. Problems that people assume are solved, but they aren't.
Yeah, so there's a fair amount of magic, I guess, that goes into it. And integrating hypervisors with Kubernetes is kind of an interesting space. So why would you actually do this? Well, Kubernetes is not built to be multi-tenant. Containers are just C groups and namespaces running on a shared kernel. And so how do you tackle the problem of multi-tenancy? Well, one way that you could do it is managing multiple clusters or, across multiple accounts, things like that. But that starts to introduce sprawl, and it starts to introduce a larger footprint that you now need a larger team to deal with. And so one of the questions that we're trying to answer is, can you use a hypervisor? Back in the day, it used to be applications ran on virtual machines. They were isolated from each other. Can you bring that principle to containers and that kind of build once, run anywhere? They're easy to manage, easy to, use a fleet of them. And can you bring the hypervisor and isolation bits to Kubernetes using this topic? So what are their current implementations in Kubernetes? And it's kind of an interesting space because there's a couple different ways you can do it. So currently there's KubeVirt, which is kind of maybe what you're thinking about as far as like virtual machines on Kubernetes. And oh yes, sorry. Ooh, yeah, that is better. Apologies. KubeVirt is what you might be thinking of. So it actually considers virtual machines to be Kubernetes resources. So you schedule virtual machines, it uses KVM, libvirt, and it kind of gives you a fleet of virtual machines that you can work with. So think of it as you're building your own internal cloud or something like that. KubeVirt would be useful for that. It creates virtual machines and manages them through a single layer, being Kubernetes. Next would be Kata containers. Maybe folks are familiar with Kata containers. And that actually takes a stab at using containers in Kubernetes, but actually providing a hardened sandbox for those containers. So they look like containers, they feel like containers, but they're actually isolated from each other using a virtual machine. And then there's something like gvisor, or there is gvisor, which is not quite a virtual machine implementation, but it's another stab at this isolation space where it's emulating syscalls to try and isolate processes from each other on the host. And that, we see performance issues with that. If you've ever run gvisor, Kata containers kind of has similar, but it can be difficult to run. And then Where we come in as Adera is actually applying this type 1 hypervisor to Kubernetes. So we're doing the same thing where we're actually providing sandboxes for containers running in Kubernetes, but we make use of a type 1 hypervisor because it's a stronger security model in that your containers are actually running in individual virtual machines on the host, or I guess next to the host on the same physical hardware.
Yeah, and one interesting thing about that is, KubeVirt takes the approach that it wants you to manage a virtual machine. And for example, it gives you the idea of you literally create like a virtual machine disk and you attach that, and you're effectively just running a virtual machine. Kata and Adera really, our goal is really to make a virtual machine feel like a container. So our technology maps this idea of a Kubernetes pod into an actual virtual machine, but it does it in a lightweight way, kind of like a micro VM. But because we're actually low level, it's not really like a micro VM. It's actually sort of just treating the hardware more or less like the actual, like it understands containers at a fundamental level.
Yeah, and one of the challenges too that I think as I've been enlightened to is, containers are kind of this build once, run anywhere thing, which works for most software. But for something like a GPU, that line starts to blur where you now need drivers on the host that you need to be aware of, and you need to match your container to what's running on the host. And using something like a virtual machine here is actually a very good solution to the problem, because now you are running a kernel per workload. So rather than your workloads having to match to a specific node running a specific version of this driver, you can start to match a kernel to your workload. So you can match the drivers to your CUDA version for your workload and run that anywhere. And you can attach a GPU through to your virtual machine. And it actually starts to make it much more flexible for certain problems.
Yeah, and like we've gotten used to this world of everything being software, but with AI, that's sort of changing a lot. Suddenly people are doing more GPU related stuff, but it's also not just GPUs. There's TPUs, there's DPUs, there's network devices. No longer is it sufficient to just softwareize everything. Hardware is now kind of making a comeback.
Yeah. So what are the challenges that we've run into? This is maybe where we start to bleed into some of the type 3 fun, but most of this is type 2 fun, where, Kubernetes actually, when I first started working on Kubernetes with these hypervisors, I did not understand this, but it makes assumptions about the existence of pods based on the fact that the C group exists. And with something like Kata containers or type 2 hypervisor, that's a process running on the host. So you can easily attach that to a C group, and you have a pod that exists in the eyes of the kubelet. With the type 1 hypervisor, we created our own CRI, which handles the RPC interface and creates a virtual machine, runs the container inside the virtual machine. So the virtual machine maps one-to-one with a pod. But in the very early days, we never launched anything in the C group. And we were actually unaware of the problem for some of our early testing, because the way that some CNIs work is they actually create C groups in a certain C group class, and it holds that C group open, if you will. And so when we deployed certain CNIs, we were getting weird errors where Kubernetes considered our pod to exist, and then it couldn't find it suddenly, and it would delete it and recreate it. Pod sandbox error. I wrote a whole blog on it. It was the bane of my existence for I don't even know how long. I had one kid when I started, and I had 2 kids when I finally figured it out.
I think also an important thing about this is the way that a type 1 hypervisor works. There is no process inside of the host that owns the VM, because it's actually in the hypervisor, not in the system that runs kubelet. So this sort of breaks the entire Kubernetes model entirely, which is what we eventually had to discover. There's sort of an interesting thing in Kubernetes, and going to step on you a little bit here, but the CRI is effectively like this interface. It's sort of like an idealized interface of what Kubernetes should be. But actually, in reality, the CRI is sort of bolted on to this greater kubelet. That kubelet has a long history going back to Google and various other things. And so we're sort of, I guess, breaking the mold of what a traditional Kubernetes pod and CRI can typically do. The CRI ultimately still thinks that there is a C group, that there is a process is running on the host. But in our system, that suddenly falls away because we're moving that below to the hypervisor itself.
Yep. So the way that we actually solve this is just by launching a process in a C group that effectively right now just does nothing, because that is one way that we have to actually fit our product into the Kubernetes mold to make it think that yes, or make it realize that yes, there is a pod that's here, even though the C groups effectively exist on another machine, even though they're on the same physical hardware.
Yeah, and one thing I'll add on there that's really interesting is it's really easy to make Kubernetes feel like it's working. It's another thing to make it actually work. There's really good demos you can create with the problem of how the host interacts with the system isn't solved. As an example, you might surmise that you could maybe do something like make the CRI just spawn an AWS instance, for example. So every pod is a different AWS instance. Actually, it runs into the same problem that we have, where the host system now no longer is bound to the thing that is running. So it breaks the Kubernetes mold entirely.
Yeah, and this actually, my third point here, the scheduling mishaps, that's a great segue into that, where you now have multiple pools of memory. So with KVM type 2 hypervisor, it runs in the shared kernel, and so you have a way of accounting for memory. Kubelet, when it reports memory for scheduling, it reports the memory that's on the host. It says, here's what's available, here's what I'm using, and scheduler, please make a decision about that. For a type 1 hypervisor, or the example of using EC2 instances, the way I like to think about it is you have your whole host, which is this segment of all of your resources. With a type 1 hypervisor, it actually slices that up. So now your host is a small amount of resources over here, and you schedule virtual machines in your virtual machine memory pool. And so kubelet, which actually runs in the host, running in the smaller amount of resources, is reporting that, hey, I have this many resources. And as you start to schedule virtual machines, it has no view into that pool of memory that you're actually scheduling against. And the way our CRI is written is you can have heterogeneous workloads. So you can run containerd workloads alongside hard isolated virtual machine workloads. And so you need a way of accounting for two pools of memory. And kubelet really just does not have that ability to account for two pools of memory, surface that back to the scheduler. So we've had to do some tricks. We currently have a hacky way of doing it, but we're actually coming out with a better way that uses DRA to actually to represent hypervisor memory versus host memory. So you can schedule against host memory, but if it's an Adera pod or a virtual machine pod, it uses DRA to represent the virtual machine memory pool that you can schedule against.
Yeah, now I'll add on one really interesting thing about that, which is, I said earlier that there's kind of Kubernetes the way that the idealized version, and then there's the actual implementation. And I think Kubernetes has an interesting thing where it's such a large project that there's a lot of theory about how it works, but the actual implementation differs significantly. There's actually a very specific KEP that you could mention here that would help us a lot in solving some of these problems.
Yes, what is it? KEP 2371 for the CRI. It's actually surfacing the resource information through the CRI, which everyone, maybe if you're familiar with the CRI, you would expect that to be happening. That's how the runtime is interfacing with Kubernetes. It's actually not how it's happening right now. It's actually cAdvisor that is surfacing those metrics from the C groups directly through the kubelet. So if someone could please come talk to me and help me push this KEP through, that would be super useful. But yeah, one way that we're getting around that is actually by creating our own metric server, because we're surfacing all of those metrics through our hypervisor for each of the virtual machines, but there's just no good way to represent them in Kubernetes right now. So various things that we have to do there. And the last second point, the last point that I'll make on this that I think is interesting is one of those things, I didn't realize coming in that is obvious now, but a lot of observability agents, eBPF makes it super useful to install something on the hosts that has visibility into everything. But actually using virtual machines breaks that entirely, because virtual machines are meant to run a kernel per workload. And so observability agents have no visibility into what your application is doing. I guess there's technically some observability into like what the network is doing and things like that, because networking goes through the host, but it has no observability into the resources, what the processes are doing, and things like that. So one of the ways that we figured out to solve that is, because you're running a kernel per workload, those kernels support eBPF, so you can install agents in each of your workloads. People don't, it's effectively a sidecar model. People don't really like that. And so we've actually built it into our product. So we have an init system and something that actually runs in the virtual machine itself. So we're not using systemd or anything like that. And that actually runs, like we recently integrated with Falco. We're working with a couple of companies to integrate their eBPF agents into our actual zone runner. And then it just forwards those metrics. So it's just scraping, you're getting the same exact metrics and observability that you would get. They're just coming from a different source because they have to come from our host.
Yeah, and I'll add on one just interesting thing that different people use observability for different reasons. My philosophy has always been that observability, particularly the security type with eBPF, was around protecting the host, and that's not actually how people use it. Oftentimes, it's just, I want to know when someone execs into my container. I want to know when someone makes a particular network call. Those are all things that are still important when you have isolation, because ultimately, if people are getting this extra security boundary, they still want to know what's going on. Protecting the host isn't the only thing that matters. And was a really interesting learning thing for us, because we kind of assumed, oh, we're providing the security. How does observability work in this case? And it's actually been an interesting challenge for us. But we do the hard thing so that the customers don't have to do it, right?
Yep. So how does it feel to integrate a type 1 hypervisor into Kubernetes? Well, it's a little bit of magic. So, we started off in the compute space by, physical hardware. You run your application on servers. Moved to virtual machines, gave a little more flexibility. From there, moved to containers, and the container space really took off. And now we have all of these applications that are supposed to be built once, run anywhere, sort of high density applications. You can pack them onto your virtual machines or physical hardware. We have Kubernetes as an orchestration layer. And so it's kind of biased towards ease of use and ease of operating, but we lost some of the security aspects. Kubernetes, like I said, is not meant to be multi-tenant. So now you have applications running next to each other, and now you're increasing the operational complexity of, running multiple clusters, because now you need to service multiple customers and things like that. And so this brings the problem to keep that ease of use, but also introduce multi-tenancy and security back into the space. And it's important as we move forward with, AI, think of something like an AI agent. What it's executing is non-deterministic. An AI agent is thinking it's doing things on its own. We don't have software that is, I wrote this software, I know exactly what it's going to do. I can predict what it's going to do. We have AI agents that kind of break that model, the threat model of Kubernetes, because Kubernetes, assumes that I know the code that's running in here, so it's trusted, so I can run it inside a container. But now we have, like I said, something like AI agents who you can run it in a container, but it may break out. It may have access to the host. It may do things that you didn't expect. So putting that inside a virtual machine is one way of, isolating the agent from other processes on the host, from doing things you didn't expect on your host. That coupled with like access controls, network policy, things like that is a good way to actually rein that back in. And like I said, with the GPU aspect now that we see a lot more on Kubernetes, it's a way of tying your kernel and kind of your lower level drivers with your application. So it brings back some of that ease of distribution for your applications, because you can tie lower level things to your application without having to worry about, are my scheduling taints and tolerations set up properly so I can deploy this application on the right node with the right kernel drivers, or I need to upgrade these kernel drivers, so I need to take this node offline or something like that. Now you just tie it to your application, you make sure it lands on the node that has GPUs, and that's it.
Awesome. Well, I think that's going to be it for us. Are there any questions on any of this?
I've got two questions. Do you support something like live migration or vMotion or whatever you would call it? And is there anyone else doing something like this? Microsoft, Xen, or whoever?
Fantastic question. So we're actually, our hypervisor is a fork and a modification of Zen. So we work with the Zen community. We rebuilt quite a lot of Zen related stuff in Rust, which is kind of an implementation detail, but is very important to us because the Zen security model is objectively the best security model, I think, in hypervisors that's available today. In terms of live migration, absolutely. We are embarking on a project which will basically give us copy on write domain support. And what this will allow us to do is, for example, fork a domain, snapshot it, send that somewhere else, live migrate the entire workload. You may be familiar that Kubernetes does not really handle this very well. And so, we're researching ways to make Kubernetes do this kind of stuff. But to be honest, like a lot of we also support non-Kubernetes orchestration. And a lot of that is happening there. But interesting thing on that same note with the copy on write, we're seeing a lot of demand for this idea of AI agents quickly making a decision, maybe being able to revert back within a millisecond in the virtual machine. So think of like you have a system that's running, you make a decision, you fork the VM from that decision, you run that. If it doesn't go right, then you revert back quickly. And so we're doing that kind of thing as well with our platform. And because of the way that our hypervisor works, it's going to be one of the most secure ways to do it.
Other questions? All right. Help me thank Alex and James for that wonderful presentation.
on the download side. So I will start it right now because I have so experiences with the Wi-Fi here. And that will boot us a Kubernetes control plane and then pull stuff from the net. And also from local, cached a little bit, but you can't run Kubernetes effectively without internet or your own container registry. All right, so why would you even self-host? The first point of the to-do list. That's an actual boat. That's not AI generated. I've taken that photo, I think 15 years ago. I always wanted it on a slide, and here it is. Okay, first of all, if you know your way around Kubernetes operations, it's actually way more cost efficient than renting a Kubernetes as a service offer. So if you have a team that is somehow experienced in dealing with plumbing level Kubernetes, getting bare bone VMs or bare metal, it will end up being less costly for you. It's also an insurance against volatility, so you never know. We all watch the news today. You never know what happens with that service partner of yours, particularly if they're operating from another country. Or even worse, you actually need to accommodate for a change that hit you already. So you're looking for a way out. And then self-hosting or at least diversifying your hosting is a good path forward. We want vendor independence of that, so whatever we're looking at should run virtually everywhere. So you can mix and match, and you can pick whatever runtime solution you fit your needs the best. Also, you may have operational sovereignty requirements because your customers require that you have full control of your stack, or internal teams require it, or you're working on a business case that needs that. And last but not least, it's actually pretty fun. It's straightforward, and you learn a lot. So that's the first box ticked off. The second, I'll just walk you briefly through our stack. For people literate in Kubernetes, there will be no surprises here. So we're looking for a free and open source stack because we're looking for sovereignty. So we need to take control. If we need to take control at some point in time, we should be able to do so. Community driven, we don't want one single party in any of the components driving their interests in that respective component. We aim to be flexible and versatile. Mentioned that already. That will be a recurring item during this talk. So this should pretty much run everywhere. Stable and secure. Well established. So ideally, people are already using it in production, and we can benefit from their iterations on making it stable and secure. Broad ecosystem support aims to the flexible and versatile part. And last but not least, easy to operate and easy to maintain. I'm getting nervous with the Wi-Fi again, so let's check the control plane node has booted. That's nice. So we can initialize it, so it'll be around in a minute. The other two demos are on cloud providers, so we're not dependent on the Wi-Fi as much. This is basically your single node. You have a diverse number of hosts to run your stack on. Might be bare metal, might be a cloud provider, might be a VM, might be a Raspberry. An host OS that accommodates for that, and Kubernetes on top. And what I'm trying to say here, if you want to kind of spread your load over most of these offers or providers, be it in a local private cloud, or be it like spiking into public clouds with the biggies of the market, mid-sized companies that have maybe more cost-effective offerings, or even regional heroes like Brightbox in the UK or Stackit in Germany. Your host operating system. I'm what? I'm not streaming anymore. The video call is being recorded. Join now. That was it. It was trying to protect me. Great. So we missed all of that. that is fine. Let's share again. That's probably good to know for the following sessions, right? Like, entire screen, and here we go. We are back. You missed the first few slides, but you didn't miss that much. So let's go back. So we want a stack that runs on all of these, and ideally come again, what? You are presenting. Show my screen anyway. Wow, it's this kind of thing now. Okay, I love this because you can measure latency that way. Okay, here we go. Yeah, so we're looking for a stack that basically abstracts you from these clouds, makes it easy for you to pick and choose and mix together whatever you want. And because I'm wearing the t-shirt, I will be using Flatcar as the operating system of my choice. There are a few choices out there that you can actually use and replace Flatcar in the stack. Fedora CoreOS comes to mind, SUSE MicroOS, and to some degree Kairos as well. It's a community steered CNCF project. In the case of Flatcar, we offer the option of having vendor-independent configuration. That sounds weird, but you'll see in a minute what I mean. It's well established. It's been around for 10-ish years now, starting with CoreOS and then becoming a friendly fork of CoreOS. It's well established. It's easy to operate and maintain. Please argue with me on that. That's my opinion. And it has a very wide support. All of these clouds you see there, private and public, it runs on. It also runs on a variety of bare metal servers. Bare metal doesn't have a logo, so it's not there, but it does. For this presentation, my host systems of choice will be QEMU. You've seen me, well, not the internet, but people here have seen me starting the control plane node already. And we can actually... Do you see that? Oh, yeah, it's visible. Okay. You can see if there's traffic. There's no traffic. That is QADM is failed. That's the demo effect. Okay. Let me real quick see if I can fix that. Okay, so the demo is here. This is the QEMU part, and we want to use the deployment configuration from the network because that's what I tested it with. And then let's just try again. All right. For this demo, hopefully QEMU, working on that. Hetzner and Akamai. The host OS is Flatcar. Kubernetes will be plain Kubernetes. We're doing this from the trenches because I want to demo how easy it actually is to diversify on the operating system configuration level. So it's plain KAS with kubeadm to initialize it. And we ship it as a mutable, updatable image. I have separate presentations on that. It's basically a way of packaging Kubernetes, including configuration and all of the bits, and shipping it to hosts, and also being able to upgrade it in place. Okay, let's get to work. So putting this all together, I was staring at this blank slide. I was asking myself, how do I demo sovereignty? What I can demo is cloud agnostic provisioning. So we're gonna take Kubernetes, basically just the Kubernetes bits, and Flatcar as the operating system, and we'll build a Kubernetes cluster from that on the hopefully three platforms that I announced. So we have the host system that is QEMU, Hetzner host, so Akamai. We have Flatcar running on that. It supports these platforms and a lot more. And we will use a configuration snippet, which I'll show you in a second, to pipe into the provisioning process, and that will tell Flatcar to retrieve a Kubernetes system extension, put it on. And then the beauty of the SysEx concept is this merges with your operating system binary. So Kubernetes bits and Kubernetes configuration will just pop up in your operating system. And when you unmerge it, they'll disappear again. So it's a very non-intrusive way of provisioning Kubernetes with full-fledged configuration and also upgrading it in place. And we're using the same config for all of the providers. You can use the very same config for all of the providers Flatcar supports. This configuration, we'll first create a control plane. So this is very manual, step by step. You probably want to automate that with Terraform or any other orchestration you're using to pull up your nodes. But we're doing it manually just to show you how easy and simple it is. So we'll boot up the control plane node, we fetch the join command so the workers can join, and then we add the join command to the workers configuration, and they will auto join the cluster. Let's see how QEMU is doing. QEMU is very fine. Second worked. The second try worked. Okay, so this has SSH'd into the control plane node and has generated the join command. So when you're right here in the Wi-Fi, you could actually join my cluster. 1 second. So we have one. So the beauty of this approach is I'm using one single Flatcar OS image for all of these nodes. I start QEMU in snapshot mode, so it doesn't persist any changes to the operating system image, and I can boot as many ephemeral nodes as my computer here is able to take. So that's the QEMU provisioning. It's ongoing. Actually, we should probably switch. And the worker nodes will take a while as well because they need to pull everything from the internet and initialize. I did a little bit of a lie when I said that we're using the exact same config. So for QEMU, I actually need a few config bits more, and the reason for that is QEMU isn't a full-blown control plane for virtual machines. It's just a single virtual machine. So I need to do a little more legwork. So when you boot a VM in QEMU, it looks like this. It can talk to your hosts via port forwards. And if you boot a control plane and a few workers, they all can communicate fine with your hosts. With port forwards, they cannot communicate with each other. And I didn't want to mess around with bridging networking support and running my own DHCP because that needs root and it's complicated. So there's a way better way to do it because QEMU supports this thing called internal networking on the host. It uses a UDP multicast bus to just connect the instances with each other. It's beautiful. And for the individual virtual machines, this is actual networking. So I need to configure that in the virtual machines as well. So there's a little bit more in the QEMU configs than in the clouds configs. Speaking of the clouds, so these are easier. Scared you for a minute, right? So these are more thoroughly automated. I don't need to start the workers individually because the script just takes care of first booting the virtual machine for the control plane and then fetching the configuration and starting the nodes. We see that QEMU is actually doing really, really well here. And it's working out quite great. So we're going to leave the clouds for a minute. And I'm going to show you the configuration. Oops. So this is what, can you folks see that? Should I enlarge it a little? Okay. time. Better? Thank you. All right. So this is a relatively short config snippet. There isn't much magic in here. I'm going to work through it real quick. There is a cloud agnostic way of adding SSH keys to the instance, and that's basically what my script does. So it takes your SSH key from your local SSH folder, the public key, and works it right into that config, so you can SSH into the machine without any issues. And it works across cloud providers because that's part of the Flatcar config. It doesn't fetch that from the metadata of the cloud providers. This is some actually pretty advanced sysx handling already. You don't need that much. Usually you just need to drop a file. We're doing some additional magic here in order to enable in-place updates. So this tells Flatcar to just go here. That's the Flatcar sysx bakery. It's mostly community driven. So if you want your own extensions, you just go to the Flatcar bakery GitHub repo, provide some instructions on how to build it, and we'll host your extension. All right, so it puts it here, and then systemd sysx will do its magic when the machine boots and will merge it, so Kubernetes will be present when the machine starts. This also has to do with updating, so we set up a timer that once every 10 seconds that checks if there's a Kubernetes update. If there's a Kubernetes update, it's going to be staged right next to the existing sysx, so you can in-place upgrade and in-place rollback. And lastly, this is the actual business logic part. This is all you need apart from the sysx. It just tells kubeadm, please initialize this node. The worker is very similar. The only difference here is that it calls kubeadm with the join command, which the script will insert. Now, the only difference in the QEMU config, which I said there, I need to do more there, is practically this part. And that's just a static configuration for a second network interface. And the script will make sure that all the workers get different IPs, and that's the whole magic. So otherwise, it's the same thing. And of course, I need to tell kubelet and kubeadm what IPs to actually use, because it's confused because there are two network interfaces in the system. But other than that, you don't need more to provision a full-blown Kubernetes cluster. Talking of the cluster, let's see how it is doing. Hetzner is done. Akamai is always done, almost done. QEMU is done. So that's my Hetzner cluster. That is the QEMU cluster. Does it still cause, what's this? Oh, that was my presentation. Okay. Should have probably kept that. But anyway. Okay, so we have 10 minutes left and we have our stack up and running. Now, someone in our call? The video call is being recorded. What is? I don't think this is working out, guys. Entire screen, share. Share. Okay. And then show my screen anyways. Thanks, Fox. All right. Wins and benefits. Many environments are supported and it's very easy to add more. You're starting with 20, 30 image types with Flatcar, and you could literally deploy it almost everywhere. The agnostic config makes it seamless to migrate from one offer to the other. So you run your nodes where it benefits you most. You can even run cross-vendor clusters this way. You can optimize for pricing, for size availability. Like I need that roughly that spec machine in that area. Which cloud provider can give it to me and then go there? You can optimize for special needs like GPUs. The whole thing is entirely community-driven. We are a CNCF project with community stewardship. We have maintainers on most continents. I'm not aware of a maintainer in Antarctica, but we're mostly EU-centric. So if that matters to you, then that is a thing. It's a well-established stack. Quite a few folks out there use us for larger cluster operations, particularly for multi-vendor clusters. That's something that we keep hearing. So users basically are already building use cases and have been building use cases on that level of abstraction that we offer. And we also the operating system of choice for some hosted Kubernetes offers. We proudly power hosted Kubernetes as well. So it works for folks who sell Kubernetes offers. It surely works for you. We have managed in-place updates. You can update base OS and Kubernetes independently. We support air-gapped environment. It's actually really easy to host like everything that you need to run an update Flatcar and Kubernetes. It's cryptographically secure. If those things are important for you, everything's signed. We have signed system extensions. That is an option. We don't want to lock you down. But if you want to lock your stuff down, it's easy to do. It's very easy to extend. We love patches. And we're also very newcomer-friendly. And it's deeply customizable via third-party sysex. Check out extensions flatcar.org to get kind of a primer on how to do that. Day 2, I needed this guy in one slide. Day 2 sovereignty. Wait, in-place updates? Shouldn't we demo that? So let's deploy an update agent. Oh, Linode is done. Nice. I'm going to deploy to Linode and Hetzner because we see here it's running 145.0 while locally we run 145.2. So we might want to update those two clusters.
What?
So this will, oh, wait, I should show you what it acts on. So in our beautiful Kubernetes provisioning config, we set up system users update, which is a lateral service to system sysex in a way that if a new system extension has to be downloaded and staged, it just creates a file, run reboot required. And that will tell QED that this node needs a refresh. QED will very carefully evacuate your pods from that node, reboot the node, and then uncoordinate so the pods can repopulate. So that's going to happen to Hetzner and Akamai. I have other plans for the local QEMU, but I'm not sure if we can make it. Because if you check here, we're running an outdated version of Flatcar. This is much newer. So I'm gonna in-place update the operating system, which will make again the cluster download Flatcar over the Wi-Fi. So please keep your fingers crossed for me. All right. So how do the other clusters look? Do we have? We have one node updated on the most recent Kubernetes version here. Apparently, here. This one is picked, but hasn't rebooted yet because it's not on 0, but it'll be updated in due time. And of course, you can configure QED much more flexibly. just exclude certain nodes or do it in a certain cadence and stop if it sees certain weird things happen in the cluster. And since both system extension images are stored on the nodes, it's also really easy to do a rollback and then reboot again, and you're on the old Kubernetes version. Okay. All right. So what is real sovereignty? Can you operate it? I hope I have, at least partially convinced you in the last 20 minutes, and that there's no magic involved here. So are you gonna pick a rented? Are you still gonna pick a rented service? Do you run your own, or do you just do mix and match? Use a rented service where it works best for you, and host your own everything else. Can you keep it stable? The upstream project, that sounds funny, right? We have a strict no bugs in stable policy. What that actually means is if we know of bugs that come down from our alpha or our beta channels, then we will not promote that respective version to stable ever until these bugs are fixed. So what you can do is if you run larger workloads, you can add a few beta canaries that test whatever is coming with your workloads, and then you report a bug, and then you have stopped that bug from transitioning to stable. And quite a few customers do that. We have a few thousand beta nodes out there using our public update server, so those already keep your workload safe. Is it well stewarded? We have maintainers from 3 companies, and we have private individuals helping it. Can you steward it? Can you not take over, but can you contribute to the project's direction? Yes, please, absolute. We're incubating project. We're moving towards graduation, and we're pushing for even more. There's a more missing. We're pushing for even more maintainer diversification. Doesn't really matter if you help on the host on the operating system side, 2 minutes. Or on the community side, if you want to join the project, we would be amazed to have you. So yes, you can steer it. But can you own it? Like grab it and then make it your own and not tell us about it? You can. We actually pride ourselves to be super easily forkable, because that's how we started. We started as a friendly fork of CoreOS when CoreOS was discontinued. And it was a bit of pain operationalizing everything. So we went through the process of insanely and thoroughly automating everything. If you want to build a release, this is what you need to do. You clone a repo, you check out a tag, you build, this should read build image. That's a copy paste. You build all the components, you build the image, and you can even run the full test suite locally. And this is all you need. We have a thorough test suite, so we don't leave finding bugs to our users. So this at the same time makes the project easy to learn and quite hard to break. You can just go wild, run the test suite, and see if everything still works. We consist of very few repositories, actually just the operating system, that's script, the test and release suite, and the update service. That's practically everything you need. And if you want to run in a very sovereign way, maybe even in an air-gapped environment, and you want to build there as well, this is how you grab all of the sources that the operating system image is made of and just cache them locally. So that works too. Let's see what the updates are doing. So we can see here that the operating, this one's the first one's about to go. Nice. Oh, the first one is finished. Look, it runs the new version, and it runs the newer version of the kernel. So that's an in-place upgraded operating system for the QEMU cluster right there. Our Hetzner cluster has almost fully in-place upgraded its Kubernetes, and Akamai has the first node on the new version, and it's just coming back. So all of these will basically roll through the clusters very slowly to make sure nothing is broken, and yeah, we'll upgrade node by node. I'm done with my to-do list, and I'm done with my time. So thank you.
Excellent work. Thank you very much for that presentation. We have a 20-minute break. If you want to ask Thilo questions, he's going to be around for a little bit. Come on over. Ask questions. We have a 20-minute break, and then we're going to come back to another exciting talk. So thank you for being here so far. In 15 minutes, not 20. We'll see you in 15 minutes.
Look, a very brave demo with Cloud and
Hey, everybody, we're going to get started here in about 5 minutes with our next talk. 5 minutes until our next talk. Minute, 1 minute until our next talk. 1 minute. Hey, everybody. Welcome back from the break. Our next talk is going to be solving operator extensibility with John and Gabriele. Welcome.
Hello. Hello, everybody. And thanks for coming. In this session, we are diving into a critical challenge that has been present in the Kubernetes ecosystem for a while, which is operators extensibility. And we'll be presenting how to solve it through a gRPC framework and interface, and how plugins can provide a concrete implementation of the interface to extend operators. Before getting started, a few words about us. I'm Gabriele Fedi, and I'm a software engineer at EDB. I've been working for EDB for 5 years. I'm a certified Kubernetes administrator and a Cloud Native PG contributor, and I work from Italy.
Hello, I'm John. I am a senior staff software engineer at EDB. I'm a Cloud Native contributor as well. I've been working with Kubernetes for 8 years, and I work now developing our enterprise plugins at EDB.
All right, let's get started. So I want to start with a question. Why would you need to extend a Kubernetes operator? Why would you need the operator to be extensible? There might be multiple reasons, so I want to mention a few of them. So first of all, let's say that your operator exposes some custom resource definition. You configure your custom resource, you apply it to your cluster, and the operator might start reconciling it and creating sub resources, whether they are pods, persistent volume, servicing, and so on. And let's say you have to mutate or modify those sub resources. So for example, you might want to inject your sidecar container, you might need to change the service type, and but your CRD doesn't expose the right template for you to update it correctly as you need. At that point, you will have to probably need to update the resource directly, and you probably will start fighting with the reconciler that would try to take back the state of the resources to its initial state. So this is not ideal. Or for example, you want to modify the default behavior of the reconciliation loop, for example, because your operator might manage databases and you want to prevent your operator to roll out disrupting changes to your databases during certain days, for example, during Black Friday, as you expect that you have a high traffic going to your application and you don't want disruption happening to your application. Another reason might be that your operator have to integrate with external SDKs to manage, for example, storage, third-party toolings, and no operator can integrate with every tools out there. So at some point, you might need to delegate the integration. So let's see what are the available options that we have today to do that. So there are several options available. So for example, if you need to modify an operator, an open source operator, for example, you can prepare your patch, you can submit it upstream to the upstream project, so to the open source project, and you can try to make that be integrated in the project upstream. The problem there is that it cannot be tied directly to your business logic, because it has to make sense with the upstream project. And even if you meet those requirements, you might be getting into the cycle of maintaining reviews that could, for example, reject your proposal just because it doesn't fit the project roadmap. Another option that you have is like forking the repo, having your downstream version of the project. You integrate your changes and you redistribute your application and you deploy it in your environments. The problem is that at the very beginning, it can be easy, but as the upstream project moves forward, you might need to rebase your project with the upstream. And depending on how heavy your changes were, you can start finding like conflicts that you have to resolve, and it cannot be easy, it can take time, okay? Another option that Kubernetes gives out of the box is using mutative webhooks. So if you have to change how resources are created against Kubernetes. You can use mutative webhooks to mutate that. So for example, you have to inject your sidecar container. If you have to change the service type, you can use mutative webhooks. The problem is that mutating webhooks usually lack context. So as you develop your mutating webhooks, you get a resource, but you have no idea what that resource is getting created. So why an operator would be creating that resource at that specific time. So even this option can not be ideal. So yeah, we have all these options available, but they all kind of sucks, honestly. So what if there could be a 4 option? We'll see that. But before jumping to that, let me introduce what we are trying to extend here, which is Cloud Native PG. Is anybody familiar here with Cloud Native PG? Hey, yeah, cool. So for who is not familiar, Cloud Native PG is a CNCF sandbox project and is an operator to manage the full life cycle of Postgres running on Kubernetes. So it takes care of the entire life cycle of Postgres running on Kubernetes. So from day 0 operation to day 2 operations. So for example, from provisioning, configuring streaming replication across replicas, and to day 1 and day 2 operations. So for example, automated failovers and self-healing if your database gets in trouble, or to day 2 operation like orchestrating backups and wall archiving or point-in-time recovery. Everything happens declaratively. So it exposes a couple of CRDs that you can configure. You can apply them to your cluster, and the operator will take care of all the heavy lifting to make it real and to keep it over time. It doesn't reinvent the wheel when it has to operate and integrate with critical operations, but it integrates with third-party toolings that are already out there, which might be a Barman or PG Backrest for backups or wall archiving, for example. These are a couple of CRDs that the Cloud Native PG operator exposes. On the right-hand side, we have the main resource, which is the cluster one. This is a very minimal configuration. So there are 3 instances and 1 gig of storage. Applying this resource, when you apply this resource, the operator will create a Postgres cluster with 1 primary and 2 replicas, so 3 instances, and each of them will get a giga of storage, so a persistent volume of a giga of storage. On the left-hand side, there is a schedule backup resource. So you define your schedule you want your backups to be created for, and the operator will create actual backup against your database according to the schedule. So let's see how the operator operates under the hood. Whenever you apply your cluster CR, the Cloud Native PG operator reconciles it, and it starts creating sub-resources, whether they are services, persistent volumes, pods, and so on. For each pod it creates, it configures it to run the instance manager's pods, which is a Cloud Native PG binary running inside the pod, which takes care of the whole life cycle of the Postgres instance running inside that pod, and it also perform additional operation like exposing metrics, exposing readiness probes, and other things. We'll see how these operations can be extended with the gRPC interface. The gRPC interface for Cloud Native PG is called CMPGI, so Cloud Native PG interface, and it is an interface that was heavily inspired by the container storage interface, which is the way Kubernetes, which is the interface used by Kubernetes to integrate with storage like AWS, GCP, Azure storage. everything starts with an interface defined in protocol files. So it is a gRPC protocol interface that plugins or drivers can implement to integrate with the operator to extend it or to integrate with the storage or Cloud Native PG. Cloud Native PG plugins runs with the on deployment. So when you have implemented the interface and you have your plugin ready, you can apply it to your cluster with a deployment in the same namespace as the operator. And the operator is able to perform an automatically discover, and it can start interrogating your plugin about its capabilities, its identities, and other metadata. Once this happens, at that point, your plugin is registered with the operator, and you can configure your database cluster to use the plugin. At that point, the operator can decide to extend some critical operation or completely delegate to the plugins some others, depending on how your cluster is configured. This is the same diagram as we were seeing before, but with the integration of plugins. So for example, when you create your resource, the Cloud Native PG operator reconciles it, but by doing that, it also integrates with the plugin during the reconciler hook, and the plugin can decide to perform additional logic, integrate external APIs, and so on. And it can eventually also decide to stop the reconciliation, requeue it, or just continue it. During the creation of resources with the lifecycle look, the plugin can be integrated to perform in-flight mutation of those resources before they get actually sent to the API servers for creation. So if you have to inject your site-back container or change your service type, that's where you would be doing that. You can also extend the instance manager with the plugin. And if you want to do that, you have to register your plugin as a sidecar container in the Postgres pods. And for example, you can define additional methods that can be collected from the Postgres instance. So yeah, let's see the protocol overview. John, over to you.
Hello. Sound good? Everybody can hear me? Okay, perfect. So like Gabriele was saying, the plugins really have two different types. There's the operator level plugins that work on the things the operator does. And then there are the sidecar level plugins that are for the instance manager level things at the Postgres level. So saying that first, the operator hooks. So the hooks are the way that the plugins can hook into. Hooks are the way that thank you, Jonathan. Hooks are the way that the plugins can interact with the flow of the operator. So at the operator level, there are two hooks. There's the lifecycle hook, and this is like mutating webhook with additional context. So the lifecycle hook would be what you would use to modify. It essentially creates a JSON patch like a mutating webhook, but it has more context for why it's being called and the state of the cluster at that time. And I'll show the proto for that in the coming slides. Next is the reconciler hook. The reconciler hook is for the control flow of the reconciliation. We use that in our in the open source plugin for Barman Cloud. We use that to check that all of the RBAC that we need to successfully take a backup is available before we start that. So the lifecycle hook is for mutating, and the reconciling hook is for the control flow. It's for executing an action before or immediately after the operator reconciles. Next are the instance level hooks. There's three of those. The instance manager by default exposes metrics, but if you want to hook in, if you want to write a plugin that can hook into that and expose metrics at the same metrics endpoint as the rest of the metrics, then you could write a plugin that use the metrics hook. Backups are specifically for backups. So I'll also be showing the proto of that in the coming slides, but the backup hook would be for like a backup CR is created. The operator sees that and then delegates the actual backup process to the plugin that has that capability. And then finally, wall archiving. It's the same idea as the backup plugin. All of the wall archiving would be delegated to that plugin. So here is the proto for the lifecycle hook, the contract between the plugin and the operator. There's two RPCs, get capabilities, which is where the plugin tells the operator what it is able to do, and the actual lifecycle hook itself. And if you look at the argument to the lifecycle hook, the operator lifecycle request, you'll see it has the operation type, which can be like create, patch, or delete. And then it has the definition of the cluster, and then the definition of the actual object itself. So like the pod. And this is what we mean when we say it's more context aware than just a simple mutating webhook. But then the reply is a standard JSON patch. Next is the backup hook. So this is an instance level hook. You can see it has the same idea where it declares its capability, and then it calls a backup RPC, and same context idea where it gets the cluster definition, a backup definition, and then the parameters. And then the result for the backup is a considerable amount of things, because all of the work for the backup is delegated to the plugin. The operator just says a backup has been requested, take care of it. So next I will do a demo. It's a very simple demo. The repository for the demo is in the Cloud Native PG organization. So everybody can get this if they want. This is a plugin that is going to inject a pause container, just the pause or image, into pods for a cluster, and it's going to add custom labels and annotations to the pod. So with that, I will put this. So first, let's see the plugin running and the operator running. All right, so you can see here that the operator is running, and separately our Hello World plugin is running. Next, we can see let's look at the operator logs really quick. So in the logs, we can see that the operator is aware of the plugin. The first log would be the operator actually registering the plugin. That log has since transpired, but these logs just show the operator is aware of that plugin's existence. And then we can look and actually look at the code here for what the plugin is doing. So the plugin implements the lifecycle hook. Oh, is this font okay? Can everybody see? Maybe I can make it a little bit bigger. How's that? Okay. So if we look at the actual implementation here, we can see first the get capabilities, where the plugin declares to the operator what it cares about, the operations that it cares about, and the resources it cares about. So on pod create and evaluates it, that's when it needs to be, when the plugin needs to be called. This is just a lot of error checking and more checking that we have what we want. And then eventually calling reconcile pod, which is where the actual interesting stuff happens. And if you look here, we take the, okay, so we get the representation of the pod coming in as the object in that request we saw earlier. And we are going to add the pauser container image, and we are going to add some labels and annotations that are defined in that cluster. So on the cluster itself, we're going to define these labels and annotations, and those are going to be injected into the pods that the cluster creates. So let's look at the cluster CR. So this is our CR for our cluster. Gabriele earlier showed a cluster example that was the most minimal example. This is that with the addition of the plugin stanza. Hello world, this is the name of the plugin, and then the labels and annotations that we will be adding, which are defined within that cluster. And then the pauser image is just always injected per our cluster per our plugin configuration. So yes, let me apply this. And what we should see will be a cluster that is created, and it will create pods that have the labels and annotations that we defined within the plugin, and it will have the sidecar that we are just directly injecting from the code of the plugin. So let's see that. All right, and if you look here, yeah, this is in the pod. The label and the annotation have been injected, and the container image has been injected. So to recap, the significance of this, we never looked at the Cloud Native PG operator code. At no point did we look at that. Our deployment is running separately, but with just some very simple Go, we were able to modify the control flow and mutate the resources that Cloud Native PG manages. So that's really been the huge benefit for us, is that we no longer need to be fully aware of what could be a complex project to make changes to its functionality. And then maybe this will work.
All right, so we saw how Cloud Native PG can be used to extend the CMPGI can be used to extend the Cloud Native PG operator, and we can say that CMPGI was a game changer for Cloud Native PG, just like CSI was a game changer for Kubernetes on how it could manage the storage on Kubernetes. Before CSI, the storage integration was directly bundled in the Kubernetes core, and storage developers has to align with the release cycles of Kubernetes to integrate with the storage of AWS, Azure, and whatever. The same way with Cloud Native PG, for example, previously there was no option to have additional tools to run backups. The Bearman was the only option available because the integration with Barma was directly coupled in the core of the Cloud Native PG interface, in the Cloud Native PG operator. Now all that integration was abstracted, and instead of issuing directly Barman commands, all that part was replaced by issuing gRPC calls to the registered plugins. Even though we took a look just to CMPGI, and we show CMPGI, the principles behind that can be applied to any operator out there that require extensibility. I think that's it. So thank you, and we can start with Q&A.
Do we have any questions?
It's like CSI became integral part of Kubernetes. Have you considered or talked of with the Kubernetes team on upstreaming this and making it part of the Kubernetes native?
Yeah, I don't know. No, we have not considered that yet. I mean, I think that's a great idea. It's pretty new. We only migrated Barman Cloud to it. I think Jonathan could correct me if I'm wrong, but I think it was within the last 12 months. It's baked now, and yeah, that could be something in the future that is considered.
Who's the next question?
Thank you. So yeah, there is a lot of subject about plugin. For example, in external secret operator. So they try to do a V2 that is only with plugins. So there is a lot of subjects about plugins, and so if you want to talk about it, we have we want to meet with some other people from external secret and some other project to talk about this kind of interface. So if you want,
That would be great. Thanks for bringing that up.
Funny enough, I am one of the maintainers of the external secrets operator.
I like seeing the audience moving.
Yeah, so I mean, I'm not directly involved with this effort of moving to plugins, but there is this angle of the security aspect of this, right? That you don't want in the code all possible providers. You know how external secrets operator works. So we have a lot of contributions from a lot of providers, and this would be a way to, externalize there are a lot of security issues, right? That could be introduced by external providers, right? And this is a very, very good way to have the code outside of the core of external secrets operator, so people don't have to have, I don't know, their one password provider when all they need is AWS secrets manager, for example. So yeah, definitely, it's something that I could be generalized. Great work. It really looks good, and I would like to talk to you as well. I think if there is anyone already talking, but yeah, well done, fantastic. Thank you.
Thank you.
Thank you very much for that presentation. If you have more questions for John or Gabriele, they'll be right over there. Our next talk will be from Graziano Castro. If you're here, please come up to the front so we can test out your laptop. We'll be starting here in about 5 minutes.
I only know.
And then you click on share.
Where is it?
I would just share both. Hey, everybody, let's get started. Our next presentation is talking about a self-improving platform closing the loop between telemetry and tuning. Welcome, Graziano.
Hello, everyone. Can you hear me right? Okay. First thing first, I'm the only thing between you and your lunch, so I will try to make it easy, fast, and I hope you enjoy the presentation. I am Graziano Casto, based in Italy. I'm working as a developer relation engineer in Nakamas. Community-wise, I'm a tech lead for the CNCF tag developer experience and a member for the Kubernetes release team. So if you want to know more about the tag or the release team for Kubernetes, just ask me in the hallway track. Today, we are going to talk about how to bridge the world of telemetry and tuning. I will show you one of the possible approach that you can use to build a sort of, let's say, dependabot for optimization. But before starting talking about the technology stuff, I want to present you some of the takeaways from the research we did in Akamas over the last year, interviewing more than 50 companies between US and Europe, from large enterprises to mid-sized companies in different sectors. First, this is the first spoiler. The biggest takeaway we had is that we were very good to build golden path into our platform, but we looked only to the building phase of the application. We created the automation, pipelines, processes, reusable services to help engineers to build their application. But once the application is deployed in production, we didn't do anything to help the engineers, the different personas inside the company, to optimize this application. The only thing we did is provide them with monitoring dashboard, nothing else. It's up to the developers, up to the SRE, up to the platform teams to understand what is wrong, where is the problem, and how to optimize the application itself. All the analyzing phase is up to them. So when I usually talk about platform engineering, I do the fine dining restaurant metaphor, because in a restaurant, you can have the most advanced tool possible, but you are as effective as the harmony you can create between all the personas involved into the services. And this is the same in the software engineering. We have different personas involved into the building of your product, and you should care, you should balance their priorities. This is true in the building phase, the one we care about when building golden path, because everyone, it's easy because everyone have the same shared goal. So ship the application faster and better. And it's become more important when you are building processes or automation to let the engineers optimize their application, because the optimization word itself can mean differently between different personas. Personas. This is the first outcome from our research. Talking about personas, we saw that almost half of these 50 companies has a dedicated platform teams. It's a good result. It doesn't mean that the other half doesn't have an IDP, doesn't have a platform. It means that for them, for this 43%, there is a dedicated team. For the other 57%, they are using spot effort from other team members to sustain, to build the platform when a need is raised by the development team. These companies are usually the companies who approach the platform engineering field with a surface level of effort, and then they are building this automation without thinking at the big picture, without thinking at how actually the developers will use the automation into their workflow. The things comes interesting when talking about the SRE team. As a trend, having a dedicated SRE team is much lower, but the usual pattern is to have the SRE team embed into the platform team, so coupling the site reliability with the application, or having dedicated team member specialized into the site reliability into each application team. This is the last one, is the most common pattern we saw into the interviews for the company. But the problem here is that when you have one or two members specialized into site reliability into each application team, you usually struggle to let each SRE in the company to talk together and build a standardized baseline for everyone. Now, we saw the different personas, but who has the ownership when it comes to application optimization? The biggest pattern is that the ownership is shared between different personas inside the company. It could be a good achievement because you can, at the first look, it can seem like everyone is working together to optimize the application. But the reality is that when everyone is responsible, actually no one is. That's the good point, the biggest problem here. And why? Because everyone, SRE, application developer, platform team, and FinOps, when talking about optimization, means different things because they have different priorities. So which are the priorities for these different teams? First, engine developers, product team, their priority is often building new feature faster. They can't afford to do a stop the word pauses. If there is some Java developer know very well what I'm talking about, to stop building new features and start optimizing the application, the feature they already shipped in the past. For SRE, their priorities is sleeping. They want to sleep at night. They don't want to have outages during nights. And how they do that? By introducing a safety buffer into the deployment of the application. The safety buffer, this over-provisioning, is the safety buffer the SRE are adding to the application to avoid, for example, out-of-memory kills. FinOps, it's the biggest struggle between FinOps and SRE is that for FinOps, this over-provisioning buffer that the SRE are adding for safety is the thing that the FinOps are trying to avoid. Because every dollar wasted in over-provisioning or idle resources is waste for them. And optimized for FinOps is optimizing the cloud bills or reducing the cost. So when it comes to optimization, there is always a trade-off between the interest of the different teams. And the truth is that there is a fight between reducing the cost, which means reducing the headroom that you add to the application to handle the traffic spikes, and reducing also the safety you are adding to your application. But the truth is that the developer is the only one who is responsible for the application they are building and deploying in production. If something breaks, the last step in the chain is always the developer. So it's the developer that have the ownership. Now, we talked about priorities of different teams. And now I want to move the conversation a bit higher and talk about the different pain points at company level that the company has when talking about optimization. The trend is that almost every company have balanced pain point between balancing cost and performance. So they want to ship performant application while being reliable. So they care about the performance, but they want to be up and running almost 100% of the time, while being reliable, of course, and keeping the costs under control. It's okay for them to add a safety room in terms of over-provisioning, but they want to add this safety headroom based on the data they have on the behavior of the application, not just for safety. And this is a reason why to build this kind of golden path for day 2 operation, we can't afford to do static golden path. You can't build, like in the first phase, golden path with only one road. You can't build something that is opinionated, because in the first step, in the first path, you are building for different teams, of course, but everyone have the same goal, which is shipping the feature faster. In this case, you need to build a golden path, which is a balance of different priorities first, as we saw for the different teams. And every application have different behaviors and different needs in terms of which parameters to tune. For example, having a configurable golden path allow you to prioritize performance on user-facing application, prioritize for reliability for critical applications that need to be up and running, and maybe stress more for cost in terms of non-critical application. The idea is that you can't actually achieve the best in reliability, so safety and cost for a single application, but you should consider the fleet of your entire application. So, tech stack. Now it's time to talk about technology. 70% of the interviewed company are using Kubernetes, one of different distribution between vanilla Kubernetes or OpenShift or something else. And the most used application runtime is the JVM, then followed by .NET and Python. And why I'm adding here the application runtime? Because Kubernetes only, the pod where you are deploying your application is just a box. You can't optimize the box without thinking about what is running inside the box. Because optimization itself, whether it is for cost, reliability, or performance, actually performance require a more iterative approach, but the size of the pod itself can influence the performance, but it's always a layered approach. You can start from the pod, but you can go down into the application runtime and up to your node groups, for example. The problem here is that only 80% of the companies interviewed are actually considering together the container, so the requested limit of the pod, with the application runtime they are using inside the pod. Everyone is approaching to the right sizing problem, to the optimization problem, only at pod level, and very few of them are actually considering how the size of the pod can influence the horizontal scaling for your application, and very few of them are actually consider how the density of your application in the cluster, the big packing, can improve your cluster autoscaler or node group provisioning. As I said, the optimization problem is a layered approach. The first one, the easiest one, is acting on the pods, okay? When you need to right-size your container, the easiest thing to do is go in there and change your requested limits for your pod. The problem is that this is a box, so you probably are changing the size of the box, making it bigger or smaller, without considering what is running inside. For example, if you are running, let's move to the other slide. If you are running a JVM application inside the container, JVM starting from Java version 10 or something is container aware, which means that if you are running the JVM without any configuration parameter for the heap size, the JVM takes 25% of the available memory, which is the container limit. So if you are provisioning a pod with 4 gigabytes, you are actually using only 25% of this 4 gigabytes, which is 1. 3 gigabytes of the memory you are allocating to the pod is basically waste. The other thing is that you should care about the application runtimes in terms of reliability. Let's keep the example of the JVM. This is a real example. This side into the circle is the host heap used by the JVM. JVM can be configured to use a heap size, which is the memory used by the application, and the host heap, which is the memory used by the JVM itself. The problem is that if you configure the max heap size equal to the container limit, and your heap usage, which is the memory for the application, saturate your heap size configured, since it is equal to the container limit, the JVM itself doesn't have space to allocate the host heap, and this causes out-of-memory errors. Third layer, HPA. You can think that horizontal scaling is the solution for all your problems. This is not true, because a right-sized container impact better on your horizontal scalability, improving your density on your cluster. And this is another reason to think about the application runtime where you are applying a horizontal scalability mechanism. This is another example. This is a performance test made on a pet clinic application, so another Java application. Below, you can see this chart. The red line is the throughput, requests per second. This is a datetime pattern used K6. And you can see that we are keeping basically the same 300 requests per second. On the left, you have before the optimization. On the right, you have after optimization. The blue line is the latency. Only by changing the configuration for the JVM, the HPA, and the Kubernetes pod, we have stabilized the latency to few milliseconds, avoiding spikes up to 240 milliseconds. And this is for performance. Above, you have another chart, which is the same observation, but considering the CPU used for the entire workload and the number of replicas. The number of replicas are the blue line. And as you can see, we basically made the HPA useless here, because we shift from 60 replicas to only one by decreasing also the overall CPU usage used by the workload. How it is possible? Because considering that the JVM is a heavy runtime, which used JIT compilation and garbage collection cycles, which compete with your application, doing bigger pods instead of few smaller pods and scale horizontally make the application works better in terms of performance, which is the ratio between throughput and latency, and waste less resources. The last thing is considering your nodes. It's here that you are actually get the best improvement in terms of cost, because once you have your right-sized application, so you are sure that you are allocating exactly the amount of resources that your application needs, you can consider, you have the data to consider to take a better choice in terms of how your cluster, your node scales, and which instance for your cluster, for your nodes are using. This is another real-world example here. I don't remember, it's probably a OCI instance. As you can see, by shifting, you can save up to 200 gigabytes in terms of memory, which is here that you can save most of your cloud bill spending. Approach. Now, doing all this stuff, considering all the layer manually, is basically a nightmare for every persona. So you can't think that developers stop 2 months and thinking about that. Platform engineers, lack of application context, SRE probably are doing something else. And so the most common pattern is to do the so-called spring cleaning approach. I stop for 2 weeks every quarter and I start optimizing the thing I did the last 3 months. The idea here is to automate all the process in terms of getting the data you need, analyze the data, and let the developer, which are the last step in the chain, to just review the recommendation provided and apply or refine this recommendation right where they are expecting this recommendation, which is a PR in this case on GitHub. The idea is very simple. You have everything starts with a good telemetry. You need a very strong visibility over your Kubernetes environment and HPA and application runtime. You have to build an invisible platform capability that can extract this data and analyze. And we want to do it configurable, which is this orange box, the tuning profiles. Tuning profiles are basically the house of rules where the SRE are giving the rules on how the pod must be optimized. And then the same analysis component can open the GitOps request. The idea is simple: import, analysis, recommendation, which is our PR, the content of our PR, and the PR. Another example of importance for tuning profile is that this recommendation is based on historical data. So I am analyzing your last month of traffic, but this month of traffic is not probably the average traffic you have in the entire year. So with tuning profile, you can define, for example, some scaling factor to say, okay, you analyze this, but I want to be sure that I can handle the double of the traffic for critical application. Let's see, at the end of the presentation, you will find a QR code. Of course, this is a demo that requires to have at least 30 minutes of data on Prometheus. So it's very difficult in 25 minutes to show it live. But there is a QR code at the end of the presentation where you can download the repository and try it locally on your kind cluster or Minikube or whatever. The idea is that we have another, again, Java application. In this case, a pet clinic application built with Java 25. I used OpenTelemetry collector to get the metrics and send them to Prometheus. And then you have also the Grafana dashboard, which is actually not useful here, but if you want to see and validate the data into the PR, you can see directly the data into the Grafana dashboard. Then I built an optimizer component. This is something that the platform engineers provide. The optimizer component is, in this case, a cron job, getting the P95 matrix for specific workloads from the Prometheus. Now is configured every 30 minutes, but you can take the entire month or whatever. The idea then is that these metrics are moved to some policies, the tuning profiles. The policies are defined using OPA, Open Policy Agent, mostly used for airbag or something. I use Open Policy Agent to define the rules that the SRE are provide for the right sizing of the container. And then this is an example of the rules. You can see the target. The SRE say, okay, for my pet clinic deployment into the microservice demo namespace, then my manifest path is up petclinic.yaml. This is needed to open the PR then. I want to keep a headroom of 10%, which means you analyze that my usage is 1 gigabyte. I want you to provision at least 1 gigabyte and 100 megabytes. And the delta threshold is, okay, if the recommendation is less than 10% in delta with what you are actually analyzed, avoid to open the PR for just a small chunk of improvement. You can define, for example, min and max for CPU and memory to give to the recommendation system max and lower threshold for your resources. And you can define the ratio between requested limits for CPU and memory. In this case, for example, I want that the limit for CPU is the double from the request defined. And you are moving, the last result there is the calling to another standardized policy, which is again another resources.rego, another Open Policy Agent module, where the platform team standardized how these settings are managed and the calculation is done. So basically the idea is that the platform engineers are giving you the optimizer. They are giving you a shard library that exposes this set of configuration. SRE create the configuration, and this is the result of the optimization. You can see that our first thing first, you have the action. So based on the threshold, you can open or avoid to open the PR. You have the new limits and new requests for CPUs, and the diagnostic section, which is all the data that helps the developers to analyze the recommendation and decide if to apply or refine. Then the data are passed back to the optimizer, which open the pull request. Once the pull request is open, you can see on your GitHub a pull request like that, where you have a table with the new limits, new request, and the JVM max size. And you have a diagnostic section where you can see the CPU observed, the memory observed, the heap observed, the off heap observed, the analysis window, which is 30 minutes before the opening of the PR, and the headroom, in this case, 10%. You can try your calculation and decide if to apply or not. And of course, this is not just the body of the component of the PR, but we already have patched exactly where these settings need to be patched inside the PR. So JDK Java option modified from 512 to 147 requested limits for the CPU and memory. Once I'm, as a developer, okay with the PR, I can merge it into main, and then you have Argo CD that I can merge into main, and then I have Argo CD that deploy back the application into the cluster. And so you are building this closed loop cycle of optimization where everyone is involved, but in a standard way. So I'm sure that I'm changing as a developer the configuration as the SRE want, because they built the rules of the optimization. Platform teams build all the infrastructure behind this process, and developers keep to be the owners of their application. Wrap up. First thing first, we are building all these processes to improve the collaboration between teams. I don't want to remove the developers or the SRE from the loop building automated agents, because I don't want for the developer to have a feeling of losing control. They should be able to be the owner of their application while making their life easier in terms of analysis. Second, the idea here is to build a sort of dependabot for the optimization. Just like dependabot do it for the dependencies of the application, you have an invisible platform capabilities that analyze your system and create PRs into your GitOps workflow. Last but not least, it's important to understand that when you are optimizing your application, you should consider the entire picture, not only the pod, but the runtime, the HPA, and the cluster itself. At the end of the day, when it comes to optimization, whether it is for performance, cost, or reliability, which is actually a chain of different things that are impacting themselves together, it's always a domino effect. Everything starts with a good visibility in your metrics. Without a proper observability, you can't build a process like that. You have the data to right size your workloads, which allow your HPA to scale better. And if an HPA scale better, you have a better bin packing of your application in your cluster, which reduce the idle resources into the overall nodes. You have the data to decide how to provision the right instance for your nodes, and how to help, and you have the right data to help your cluster autoscaler to scale better. And then you can say that you reached your optimization nirvana, let me say. The presentation is finished. This is the QR code to the GitHub repository. I hope this is the right QR code. In case, let me know. I will share with you the right one, but it should be the right one. If you have any question, I'm here to answer. Thank you.
Great work. Thank you very much. Do we have any questions? We come back to where you are.
Earlier you mentioned like with the JVM, you want to run larger
Yeah,
pods. Oh, how's that? You mentioned with like JVMs, for example, you want to run larger pods. Are there any programming languages or runtimes where you would want to run more smaller pods?
It's very related to the runtime. The things about larger pods is better than smaller one is true for the JVM because of the JIT compilation and the garbage collector cycle. Just to give you another example, for the Go programming language is the opposite, for example. But it depends also about your specific application. Because even for the JVM, if you are using, for example, something like the native image with GraalVM or Project Crack, it makes things different. So it depends on your application specifically. Yes.
Hello, I've got one question. Because your solution is just, let's say, quite big.
Yeah.
Oh, sorry, quite big. You have the task optimizer. You just send a peer request to just update that. How you can compare that with virtual pod autoscaler?
I can't hear you. Can you?
Virtual pod autoscaler. So we can just take the metrics. If you need more, you can in 133 Kubernetes you can autoscale without restart, even if with JVM.
Okay.
So maybe this is also a solution that
You are
can,
talking about the in-place pod resize.
yeah.
The problem with in-place pod resize is that you can edit, you can change at runtime the requested limits for your pod, but if you are using the JVM, for example.
No. You are talking the new version in 133 without restart to pod. You can increase the CPU request and
Okay.
CPU limits.
Okay.
So in that case, you can just define the ratio. And if you are using more, virtual pod autoscaler can increase that for
Okay.
some time. For example, you have spike of traffic and you need to increase on this particular pod without touching it.
Okay, you are talking about the VPA, right?
Yeah.
Okay, the problem is that the JVM itself doesn't allow you to edit the maximum size around time.
But you can use percentage if.
But it is the same because the percentage is based on the initial value of your limit. So if you change the container limit to 4 gigabytes from 2, the 80% is already based on the first 2 gigabytes you defined. There is an issue open on the OpenJDK project to solve this problem. There is another. To be fair, there is another setting. I don't remember the exact name, but this is like max threshold heap size or something that can be edited at runtime, but you need a sort of workaround to patch it in synchronizing with the VPA working. So it's tricky to align the Kubernetes and the Kubernetes and the JVM together now. But yeah, it's theoretically possible. Yeah.
Thank you very much. Any more questions for Graziano? You can just catch him right here on the side. We now have an hour 30 for lunch. There's lots of great places nearby. I've heard a recommendation for Will's Cafe, which is just up the street a bit. There's also Burger Zood, which is a little further on. And then just down by the train station, there are also just a number of restaurants. So we'll see you in 90 minutes, an hour and a half from now. I hope you have lunch with each other and have a wonderful time.
I can just exit from the Google Meet, right?
I didn't know.
Hi, everyone.
Hey, everybody. We're going to get started here in just a couple minutes. Our next talk is going to be by Abdel talking about pod right sizing. So grab a chair. We're going to get started here in just a couple minutes.
Thank you.
Hey, welcome back from lunch. I hope you all had a wonderful lunch. We're going to get started here with Abdel speaking about pod right sizing in the second decade of Kubernetes. So help me welcome Abdel.
Thank you. Hi, hi everyone. I'm gonna talk a little bit about what have been going on actually in the Kubernetes space around resource management for pods. You probably all have seen some kind of features that have been released over the years. We started with live resizing of pods and stuff like that, but my talk covers a little bit kind of all of what's going on and what's coming. But before I get going, I assume everybody here knows what Kubernetes is, but I'm going also to go with the assumption that no one knows anything about Kubernetes. So I'm going to do a very quick primer about resource management. You probably have all seen this, right? Like when you create a pod, you have to give it resource requests and limits. The resource requests are expressed in CPU and memory. If your pod exceeds its memory limits, it gets killed, put out of memory. If it exceeds its CPU limit, it gets basically throttled or slowed down, right? Up to, I believe 1.28 or 1.27, you could only define resource requests and limits at the container level on the pod. And so each container within the pod will carry its own resource requests and limits. And the only way for you to kind of limit what the pod can do is quota at the namespace level. You could define quota so you can kind of control what kind of resources the pod claim. In 134, these have been introduced actually, I think in 128, and then it moved to 134 beta. They actually have moved or introduced resource limits and requests at the pod level itself, so not at the container anymore. So you could define them at the pod level, and then the containers within the pod can share those resource requests and limits. So this is quite new, or relatively new. How does that actually, when you create actually resource requests and limits in Kubernetes, how do they translate into the container itself? So this is essentially how it looks like from cgroup's point of view. When you define, let's say, a CPU of 220 M, that's 1/4 of a core. And that essentially gets translated into something like one core is 10 to 24 times 0.5, which is 1/4. So that gives you 256 shares. And then the limit is defined in essentially the same way. So 500, that's basically 1,000 times 0.500. So that's essentially from a CPU point of view, it just defines the amount of, so I think if you're sitting there, you don't see the slide. Sorry about that. Okay. It just basically defines the amount of time your pod has access to the CPU. And it just boils down to the number of milliseconds that the pods have access to the CPU. Memory limits are hard-coded at the memory level. Since a very recent version of Kubernetes, I don't remember actually which one, there was also introduction of swap use. So you could actually use disk space as memory. So when you define memory at the pod level, that gets translated into memory in the node itself, but memory also in the swap if you have swap enabled. So you have to have it explicitly enabled at the kubelet level. So the question, how do we right size a pod, right? You have essentially kind of three ways to think about this. Kubernetes itself doesn't really have a concept of quality of service, QoS. For those of you who are as old as me and have been doing networking, QoS is essentially a way for you to define priorities between packets in a network sense, but also in the resource sense, you could define those, but not in the way you think about QoS. If you basically define resource requests and limits with a certain gap, you have guaranteed quality of service. Because if these pods get scheduled, it's not going to be actually running unless the kubelet can ensure that those resource requests and limits are available on the node itself, right? So that's what we call guaranteed. You have burstable, which is when your resource limits are higher than your resource requests, in which case the pod can burst into those extra available resources on the pod. And this is also sort of guaranteed because you have a request there, so the pod is not going to be scheduled unless there is 1/4 of a core and 64 megabytes of memory available on the node. And then you have the YOLO mode, which is best effort. So that's essentially when you don't define any pod requests or limits and you let the pod kind of figure it out, right? Why these things are important is because if you are, like you have seen this trend among cloud providers recently where they're moving, like most cloud providers, specifically Google and AWS, are moving toward pod level pricing. So when you create a Kubernetes cluster, you don't actually even provision the nodes themselves in the first place. So that's essentially AWS. I don't remember what AWS call it. We call it GK Autopilot, but AWS has a version of that where you create a pod, it only creates the control plane. There are no nodes. You schedule the pods in the first place, and then the nodes get created. And then you only pay for the resource consumed by the pods. You don't worry or you don't care about the nodes themselves, right? That's where these things becomes very interesting, right? So in both AWS and Google function the same way. If you define the guaranteed space, actually both this type of auto or fully managed Kubernetes offering will not allow you actually to even schedule the pod in best effort way. They will have some webhook that will just reject the pod because they say, hey, you have to tell us what's your request. What do you want the pod to have? So if you define it in guaranteed, then you have the guaranteed. If you define it in burstable, usually what the cloud provider does is they provision a node which is slightly bigger than what your pod requests, and they allow you to kind of burst and consume those extra resources available on the node. So these are very important to keep in mind if you are going to use a fully managed version of Kubernetes somehow. So when node, of course, experience pressure, then the kubelet will evict the pod. So that eviction happens on memory. Basically, that's the pod will die with out-of-memory exception. If you have CPU or you're running or the node is running out of CPU, then your pod will be throttled up to the point where there is something I'm not mentioning here, but there is this concept also of priority class, right? So when you define pods in Kubernetes, you can define them with different priorities. And so if you have actually pods of lower priority that are consuming or hogging all the resources on node, and then pods of higher priority get scheduled, then the lower priority pods will be evicted, right? So that's something also to keep in mind. So this is just some sort of visual representation of how this works. So I have a node that has a certain amount of memory. The guaranteed pod will have its guaranteed resources, so it's kind of run happily over there. The burstable pod will be able to burst into whatever available resources up to the point that more guaranteed pod will come in. And then that kind of resource available for burstability will start shrinking, right? As guaranteed pod are getting scheduled. And if the pod just exceeds all the burstable available resources, it will get evicted, it will get killed, right? So this is a case where the burstable pod is requesting 1 GB of memory, but is actually consuming an extra gigabytes. And that's a little bit less than what's available on the pod itself, or around what's available on the node, sorry. So for CPU, we talked about this, the pod will be throttled. So the question is there a better way actually to handle this kind of resources dynamically? Because up to now, you have to kind of, you have to define the pod resource requests at the beginning before you deploy the pod, right? And if imagine you're a platform engineer in a situation where you have a platform and then you just go to all your teams and tell them, hey, folks, please make sure that your resource requests are exactly what you think or what your workloads need. How many do you think will actually set theirs to a reasonable amount? None. Everybody will just set them to the maximum amount that they think, because everybody thinks their workloads are more important than everybody else, right? So in Kubernetes 1.26.7, sorry, an alpha feature was introduced called in-place pod resize, IPPR. So in-place pod resize allows you to basically resize the pod without restarting it, right? So you can just add more CPU and add more memory. That became beta in 1.33, and I believe it's planned to be GA or it's already GA in 1.35 or 1.36. It's already GA. I think it's V1. 3.5, yeah, thank you. So in 3.5, it's already out. So what you do is you define the resources as normal, and then you define something called the restarts policy on each of the resources. So for the CPU and for the memory. So obviously the resource policy you're going to define is not restart, so that the pod doesn't get restarted. And then you actually have, so when you are resizing the pod, the resizing itself will get reflected in the status part of the pod. So you have a way to track if the resizing actually happened. A question I get very often when I talk about this topic is, will a pod get resized if there are no available resources on the node? Obviously not, right? If there is no available resources and you try to patch resize a pod, it will just be rejected. It's not going to be resized, and then you will get it in the status, like something like error pod cannot be resized. So this is usually how you do it. You basically just patch the pod, and in the patching you pass your new resource requests and limits, and then the pod just doesn't get restarted, right? I have a bit of a demo. But before I go there, so the fact that we can actually resize pods creates quite a lot of interesting possibilities. And I'm going to talk about one particular one. You all know what VPA is, vertical pod autoscaler. So VPA historically have been used in kind of two modes. You can use it in what we call auto mode or off mode. So auto mode, you write a VPA, a vertical pod autoscaler, which if you set it to auto mode, it will automatically resize the pod. But when it's resized the pod, it just basically kill it and create a new one, right? If you set it into off mode, the off mode, essentially, it's not going to restart the pod, but it's going to give you recommendations. So if you query the VPA, it will tell you, hey, we think that this pod has to have this amount of resources available, or this amount of resources for the request. There is a new version of VPA coming, which I'm going to talk about in a bit. Yeah, so this is how it works before. Now with VPA, we can actually resize the pod, and that's the part I'm going to talk about in a bit. So one interesting thing we could do with this live resizing of pods is something we call it CPU boost. CPU boost is essentially giving the pod more resources at startup time and then removing the resources when they're not needed. And that's very valuable for a lot of workloads, aka Java. When you are doing JVM-based workloads, the JVM needs a lot of CPU cycles during the starting time to be able to do all the Java classes optimization thing. And then, so historically what people have been doing is that they oversize the pod to make the application start faster. But then now with this new kind of live resizing, what we could do is we could give the pod more resources during the first like two minutes or something, or up until the pod is ready. So that's when the application itself is ready to serve traffic, and then remove these resources after, right? So resize it down or shrink it essentially from a CPU point of view. So let me show you a quick demo of how that looks like. I'm gonna pause a couple of times so I can explain to you what you're looking at. So what you see here is in the top is just where we do kubectl apply. Under that, we have a Spring Boot application which is running, and then in the bottom we have metrics. Let's just keep going. So this is a situation where, let me move it a little bit further. Yeah, so we are requesting 200 milli CPU and limit is 500, and then requesting half gigabytes of memory, right? So notice this counter here, which essentially tells us how long it took for the pod to be ready. So it's going to take roughly about 40 seconds. So that's 42 seconds, right, for the pod to be ready. So this pod, particularly Spring Boot using Spring Boot 3, I believe. And in this particular case, we actually set a readiness probe on the pod. So the pod is not considered ready until it serves like HTTP 200 or something, right? Now, with CPU boost, so pay attention to both the age and then these two numbers here. So you see here that we are giving basically the pod 2 CPUs initially at startup time. It will take roughly 10 seconds for the pod to start, to be ready. And then these two numbers will go down. See? Right? So you're asking me, how did we build this? So when pod resized was introduced, like 127, me and the colleague, we built a proof of concept. So this is based on a proof of concept that is on GitHub, but I don't recommend using it for production because we haven't touched it for 2 years. But it's based on, so we basically wrote a new CRD, we call it CPU boost or startup CPU boost, which leverages the live resize under the hood to CPU boost the pod. So we just define the CRD, you define which label, you target which pod you want to CPU boost, and then you define the limits, like I want to CPU boost by a factor of 100 or 200% or whatever, up to a certain status, up to when the pod is ready, or up to 3 minutes or something like that. And so this demo specifically is based on that. But the goal of that proof of concept that we have made was to actually try to push this upstream to Kubernetes. And that's where VPA is coming into the picture. So the new version of VPA is going to have this kind of CPU boost capabilities in it. There is already a KEP, Kubernetes enhancement proposal, which is already live, and it has been accepted, and they're working on it. I assume the plan is for at least something like this to come in 136 or 137, but like this year, basically, at least some sort of alpha version of the new VPA version 2 with alpha. So we're going to have extra fields in the VPA that allows us to do CPU boost. All right. So we have done some tests with this. So with like Go, Python, Java, C#, and Node.js. Let me show you a quick one for Go. So what you see here is on the left side, we have a bunch of pods, and on the right side, we are just running a Go mem test. So the right side is going to scroll quite a lot, so don't pay attention too much to that. But you can see, I'm going to pause it. The pod has like 1 gigabyte as a limit, right? So I'm going to speed it up, fast forward a bit. Where, yeah, we run this script. So this bash script just ran the kubectl patch under the hood. And then you will see that when we run it, come on, it's going to resize the pod. And you see here that it's 1.907 gigabytes. So for Go, it's a no-brainer. If you resize the pod, the Go runtime will just pick it up out of the box. I got this question quite a lot about Java. Java, if you're running inside the JVM, you can basically define a JVM flag that defines the memory inside the JVM as a fraction or percentage of the available memory in the container. I don't remember what that flag is. It's something like -x something, because all JVM flags start with X. But if you're running something like a native Java application, like GraalVM or something, it should behave the same way a Go application behave. The GraalVM runtime will automatically manage the memory for you, right? So yeah, so these are some of the tests. Here we say we put this no on the memory resizing for Java because we tested it with JVM, and we noticed some weird behavior. We already actually raised a couple of bugs to the Java team to fix it. But we have tested it also with the GraalVM, so native images, and it just works out of the box. All right, that's it. That's all I have. I hope this was useful. I'm not sure how am I doing on time. Okay, then I have time for questions.
Any questions?
Hi, I have a question about Go, especially in regards to CPU quota. If you were to increase CPU quota, but then Go runtime has the Go max procs field, I mean, it needs to be scaled up accordingly to make use of, let's say, a larger quota. Is that something the VP accounts for, or is the service owner expected to tweaks?
We have actually done some. So the question, yeah, we have done some tests on that, and we noticed some kind of strange behavior in the Go runtime. We actually asked the Go team to clarify it for us, and the answer we got is essentially that's not a flag you're supposed to be setting yourself. The CPU flag
max?
in the Go CPU, yeah, the CPU max thing. Yeah. You're not supposed to set that. Just leave it out, and the runtime will automatically figure it out for you. That's the answer I got from the Go team. Okay. So I don't know, like, because when we did something, actually, the test we have done on Go was not even Kubernetes. It was Cloud Run, which is our serverless platform, where we have a CPU boost feature, and we were trying to figure out if setting up the CPU boost for Go speed up the startup of the application. And then we did quite a lot of tests. We noticed some very weird behavior, but the overall advice was don't set that flag. Just leave it out. Also, the other thing that we noticed with Go is that when it comes to CPU boost specifically, is that the architecture of the CPU under the hood will create different behaviors depending on you're running on which CPU architecture, ARM, not ARM, all that stuff. So
I see.
But the TLDR is just don't set that flag.
Okay.
Right.
Cool. Thank you.
Cool. Any other questions?
Any other questions?
Yeah. There was one question here in front.
Hello. I wanted to ask about the CPU boost thing. You mentioned it yourself. It's in Cloud Run.
Yeah.
Is it the same thing on Kubernetes, or there's like implementation differences?
The upcoming VPA version will have the same behavior. The implementation is different, but it will have the same behavior. So let me show you actually that. I'm going to show you the proof of concept we built, but not the actual VPA version, because I don't know how that will look like yet. This is what we built, right? So the demo I showed earlier for the Spring Boot application, this is the CRD we have built. This is not going to ship. This is, again, the thing that I don't recommend for production because we didn't test it. But you see here, we just say startup CPU boost. We set the targets for which pod we want to CPU boost. And then we set the percentage of increase, so 50% more. And then we set a duration policy. In this case, up until the pod is ready, but we can also set like 2 minutes, 3 minutes, whatever, right? If you're asking specifically about Cloud Run, there is a difference between, the key difference is that Cloud Run only CPU boost for 2 minutes. And it's not flexible. It doesn't actually give you the option to extend that amount of time, right? So if your app doesn't start within 2 minutes, it's not going to get the CPU boost feature. But the new upcoming VPA, which will have these kind of things, will have flexibility to define more time if you want. Make sense? I mean, and if your application takes more than 2 minutes to start, that's a different problem that you need to solve somewhere else, I guess. All right. Any other questions? Either this was super clear or no one have freaking idea what I was talking about. Just kidding. I'm just kidding.
Thank you very, very much.
Thank you.
We're gonna have a little break, and then we're gonna welcome Maxime. So Maxime, coming up.
All right. Thank you, sir.
Good job. Yep. Get connected, and I'll have you connect to that. Yeah.
Okay. Yes. Yes. But then the question is, what's causes those spikes within your application? Do you know, or yeah, it's usually caused by, do you know? That's usually caused by like no, yeah, exactly. So yeah, that's usually what causes. I'm wondering after
Oh yeah. Okay. Oh yeah. I was looking for that. Yeah. Perfect.
A little spotty, but yeah. So.
Oh, I'm connected on my
Okay.
on my phone with my phone. Yeah.
Great. So go to meet.google.com.
Yep.
MQT.
Oh, dash. Oh yeah. Yes.
There we go. I'm gonna hit connect. You might have to restart the browser if you haven't done this already.
Perfect. Thank you so much to be here today. My name is Maxime Cockrell, and today we will talk together about Kubernetes forensic, and more specifically about how we can perform an investigation of a compromised Kubernetes cluster. Before to start this talk, a quick disclaimer. Any view or opinion expressed in this presentation are only my opinion and not necessarily reflect the opinion of my employer, management, or ownership or employee. 2 seconds about myself. I'm Principal Cloud Security Architect for the Royal Bank of Canada. Additionally to that, I'm also a CNCF Ambassador and a Microsoft MVP on the Azure and security technology. If you're interested to reach me after this talk, feel free to do that. I'm available on LinkedIn. And if you have any question on security, specifically about Kubernetes, if I can help you, that will be with pleasure. Okay, now let's jump. Forensics, specifically about Kubernetes security. As you can imagine, that is something very complex to perform because we have a lot of ephemeral components. That means we are spin up pod, we are spin up Kubernetes resource, and all these resources are ephemeral. That means sometimes it's very challenging to have the right log to perform an investigation. From people who know incident response and more specifically forensic investigation in the traditional world, what they did, they perform like investigation at the node level. That means they are doing investigation of a file system or memory of a specific node. But now, if we step back, I believe for this presentation, it's important to understand the 3 major pillars of a Kubernetes forensic investigation. The first thing is evidence acquisition. That is, we want to be able to perform and to collect the right evidence. Second point is integrity preservation, because if you collect an evidence and this evidence was alterated and this evidence is not immutable, in reality your evidence has completely no value. For that you can leverage like cryptographic hash for the evidence you are collecting. And finally, not the least, is incident reconstruction. Specifically for cloud security team, that is very important to perform post-mortem when you are doing like a cloud security investigation, because everyone is learning from the post-mortem. But now I will take the time just to explain you a quick story. Just for the disclaimer, it's a fictive story and nothing related to my employer. Imagine we have an SRE team, and this SRE team has a right solution for telemetry to monitor Kubernetes cluster, and they discover an unusual CPU load on a specific pod. That starts like that. What they did, okay, maybe we will reach our SecOps team. And because the SecOps team has a proper tooling in place and they have like a KSPM, for people who are not familiar with KSPM, it's a Kubernetes security posture management. They have a right solution, a very expensive solution in place. And they are, finally they discover, yes, in the 500 alert they have in the solution, they have an alert about this specific pod. A moment later, finally, they decide to engage an incident response team to perform an investigation because they don't have forensic capability in their very expensive KSPM solution, and that is a reality right now. For that, they want to perform this investigation, and for that, they can start from different angles. The first thing they can do, they can check at the node level. They can pull the OS log, the kubelet log. They can check also some container runtime log, the network connection. That is something that is something possible to do, but it's something very challenging, specifically if you have a very large Kubernetes cluster where you have sometimes thousands of pods. That means you have a very large image, lot of log, lot of information, and also a lot of garbage. Second point, what they can do, they can perform some investigation directly at the API server level, check the API server audit logs, the etcd snapshot, and what is also strategic is airbag configuration if you had any modification about that. And also they can work with the Nextdoor team to perform some network traffic. But all of that is like not a very new approach, because that is a very classic approach. People who are performing incident response and forensic investigation on a regular VM, they have the same approach. They are checking logs, they are checking network flow, but nothing very specific to Kubernetes. But in this presentation, I would like to take the time to speak with you about container states. That means I will present you how we can perform an investigation of a specific container. And for that, we will explore together the memory of the container, the file descriptor, and some information about the process we can have. Forensic container checkpoint. What is that? What we want to achieve in this case is we want to perform like a snapshot of a specific pod which was compromised, and we want to perform a snapshot of that. This feature is a feature available since the Kubernetes version 1.25 that was introduced in alpha. Now we are in beta with Kubernetes 1.30. And what we will do with that is we will perform a stateful copy of the running container, the container which was compromised. To perform that, we will use an external tool called Cryo, which will help us to freeze the pod and to perform the snapshot. With this capability, what is very interesting in this case is, yes, you can create a snapshot. We will do an investigation of the snapshot, but you have also the capability of restoring the snapshot to a similar node. If you're interested to know more about that, we'll invite you to check this GitHub pull request where you will have more information about this initiative. All that works. That is okay. What the guy from the cloud security team will perform, he will send a specific request to the kubelet, and I will show you the request after that. And at the kubelet level, we will trigger a specific snapshot, and the snapshot will be stored directly on the node in tar format. And after that, we will collect the snapshot and we will perform our investigation. More in depth, all that works. For that, we will leverage this external tool, Cryo, which need to be installed on the node. We will freeze the process, collect the process information. We will also save the memory, save the file descriptor, save the process hierarchy, the CPU states. And all this information will help us to perform this investigation. But now, if we go more deep, in this case, if I want to perform a kubelet checkpoint snapshot, I will use this native curl x post command. Now, if you imagine my previous scenario, that is the first step the incident response team will do. That means they will collect the evidence, and in this evidence will be stored in varlib kubelet checkpoint directly on the node where the pod was running. As you can see in my command, I specify the pod and I specify the container. Because in reality, what is very helpful for the investigation is what we have at the container level. Now, if we check the anatomy of a checkpoint, what we have inside our checkpoint, we have some strategic information about the PS3, about information related to the memory, to the file descriptor, to which mount was performed on the container. Additionally to that, we will also able to dump the memory of the container. That is very strategic because in the memory we have a lot of critical information. Specifically, if you have any key or any certificate loaded in memory, we will be able to dump that and perform our investigation. To play with a snapshot, for that I would like to take the time to introduce a third-party tool called Checkpoint CTL, which will help us to start our investigation. As you can see, with a simple command like checkpoint CTL list, I have information about the container. In this case, it's my container name is web, the specific image, the runtime when that was created, the engine used for that. But all of that is very classic information. Now, if we go more deep with a checkpoint CTL inspect with a --PS3, what we can see is we can see all the process running on the specific container. What is interesting in this example, in the process tree, when we perform an investigation, we can see we have two suspicious processes. The first one is a bash. That means someone has an interactive shell to the container, and additionally to that, we can see another process called CryptoMiner. In the real life, is more complex because they don't use a process called CryptoMiner. But additionally to that, we will continue to perform the investigation because now we want to understand how the CryptoMiner was introduced, and for that we will check the file we have in the checkpoint.tar snapshot. And as we can see in this case is, we have like a folder called /tmp/.pun, and we have also some information about the CryptoMiner which is running in /tmp, and additionally to that we have also some information like miner.logs which are related to the CryptoMiner. Okay, now we will continue the investigation because yes, we are at the point where we know yes, we have a CryptoMiner running. Someone has interacted directly with a container to download this CryptoMiner, but we don't know from where the CryptoMiner is coming. And for that, we will continue to inspect the memory. And in the memory, we can say, hey, in this repository /tmp/.pun, we have a file called systemupdate.sh. Oh, that is maybe something suspicious. And that is an information we can extract directly from the memory. If we continue to perform our investigation in the memory, we can see we have a shell script. We have more information about the shell script because the shell script was loaded in the memory. And in this shell script, we have some additional information about some hash rate, used by the CryptoMiner, and also some information about the additional file used by the CryptoMiner. We continue the investigation because we still don't have the source from where the payload was downloaded, our malicious payload. And from what we can see from the memory, we have a curl command. And if you can see on the screen, that means the people, the guy who compromised our container in this case, from an interactive bash shell, they had access and they will be able to run the command curl and to download the systemupdate.sh file, and the systemupdate.sh file was created in the downloaded in the repository /tmp/.pun/systemupdate. That is very, very, very interesting because in this case we know directly from the memory from where that was downloaded, and we will be able to continue our investigation. Same thing. What I would like to highlight is in the memory. In this case, we have lot of information. We have also some information about the CryptoMiner itself. All of that you can perform that directly with a native command like just a string and check the page.emg file. But now, if we step back and we want to reconstruct the attack timeline, because that is what is very important in this case. In this case, we discover a lot of things. The first thing we discover, someone has an interactive shell process was started, and on the container, we identify the bash. We identify the attacker created staging repository /tmp/pun to put the payload, and the payload was downloaded directly from the website zigmax.net/systemupdate.sh. That was a shell script which was used to deploy the CryptoMiner. After that, we have seen the CryptoMiner was launched. We also see some information about the hash rate of the crypto miner. Yes. As you can imagine, that is a simple scenario, because in real life it's something more complex, because what the attacker will try to do is he try to obfuscate the code specifically. Sometimes they use like a XOR method or any advanced crypto to encrypt the file. But what I would like to show you in this presentation is all that could be very simple to start to perform an investigation and start to play with the memory. But now you can say me, okay, that is great, but this solution has some limitary. As I mentioned, this feature is still in beta, but we have some limitations, specifically about network. When you try to perform a snapshot and you have like a reverse shell open with netcat, that fail. We have also some limitation with if your pod is leveraging a GPU workload. Also, as I mentioned, this solution can be used also to restore a container to another node. If you want to perform that, you need to be sure you have the same architecture and the same type of kernel. And in the information we collected, as you can see, we collected some information about the memory, which is a real gold mine. But also we collected some information about the process, about the file descriptor, about the file open on the specific container. But when we perform a snapshot like that, we will be not collecting information like persistent volume, for example. All of that need to be done manually. That requires also some advanced privilege to be able to play with this checkpoint creation. For that, you need to have privileged access to the kubelet, which is running on the node, and your node need to have like the Creo tool installed on it. And we have right now a limitation, because that works specifically if you have on-prem clusters. That means if you are leveraging like managed Kubernetes clusters, such as Azure Kubernetes services, you can't use this feature. What I would like to highlight to you, when you need to perform a forensic investigation, you have a lot of source of truth, what is possible and what is not possible. As I mentioned, right now, the biggest limitation is with managed Kubernetes version. But if that is not possible and you still have an investigation to perform, you have a lot of strategic information stored in the, for example, in Azure, in the Azure diagnostic log, in the etcd, and you are still able to SSH to the node and perform like a GDB command to do a memory dump of the node and do a full offline investigation of all the memory from the dump. With my approach, what I presented to do and what I like in this case is you have only the memory of the container itself. But now you can, for a lot of organization, yes, it's great to be able to perform that. But if I want to speak about the real life with you, if you don't have a proper playbook in place and tested, that has no value, to be fully honest with you, because the day we will have a real compromission, you need to be able to perform this investigation. And for that, if you have never played and never tested that, is not the good moment to do that. And that is very, very, very important to take that and to have that in consideration, because from what I can see from the market, all forensic playbook, that is something we try to, it's very easy to miss because people are building a playbook to react when they have like a security alert. And a lot of people, what they will do is, the first thing they will do is that will just kill the pod and that's all. But if you are doing that, you are killing, all the evidence and you will be never able to reconstruct all the timeline. And what is very, very strategic is you are learning from the timeline, from the attack path, and that will, if you don't have all the full story, you will be never able to put the proper security control in place to block that. For example, in my case, what we can see in this case, if we want to remediate that, we can put like a network policy in place. We can put like additional security control in place with OPA policy or Kyberno policy. Now, if I conclude this talk, just a few takeaways. As you have seen, containers are ephemeral, and that is the biggest challenge. What I will recommend you in this case is when your amazing KSPM solution fire an alert, is automatically to have to send a trigger to perform a Kubernetes checkpoint. In this case, it's better to have the checkpoint and perform the investigation or not. That will be your choice. But in this case, you have that, and you will be able to do your investigation. As you can see, as I mentioned in this presentation, container runtime artifacts are extremely valuable, specifically the memory, because you have a lot of information in the memory. Sometimes some people say, hey, but you need to have also the good timing. You need to be able to perform the checkpoint at the right time to have the information in the memory. Yes, if the confirmation happens and you perform the snapshot only at 2 weeks after that, yes, in the memory, your memory will be with garbage information and completely blank, and that will be very painful in this case to perform this investigation. And also, what is very important and not to miss is the Kubernetes control plane. That is a real gold mine because you have a lot of information about the pod creation, pod deletion. People try to do kubectl port forward. That is something we miss, but it's very strategic when you build like defensive use case to leverage this type of source of logs. That's all for me. Thank you so much. If you have any question, feel free to ask your question. I wanted to highlight they created a new working group for Kubernetes checkpoint. If you're interested, you can contribute. And if you have any other question, feel free to reach me. Thank you.
We do have some time for some live questions.
Yeah, perfect. Yeah, good. I will try to answer. Yeah.
Is it noticeable by the pod when you create a snapshot?
Sorry?
Is it noticeable by the pod when you create a snapshot? So could they determine that you are creating a snapshot, that you're doing forensics?
I'm not sure to understand.
So you're having a pod that is probably hacked or something,
yes.
and you want to investigate it. So with Cryo, you make a snapshot of the running container, or the running pods. Could they see it?
Yeah, if the compromission is at the pod level, in this case, it's better to perform like a snapshot of the node itself versus a specific pod. If the compromission is directly at the node level, that will be my recommendation. Yeah, because what we can see and what people try to do is they try to compromise a pod, and from the pod they try to do lateral movement to compromise the node. And when they compromise the node, after that, with the CRED from the node, they try to compromise directly the API server, the control plane, and move laterally from the control plane. Sometimes to do also lateral movement. If you are in the cloud managed solution, to try to compromise other services like for example Azure SQL database and leverage like managed identity or any service principal. Yeah. That is something we are currently seeing a lot, in terms of attack. The entry point is yes, the entry point is a pod, but the full path is pod, node, and after that try directly to go to the cloud provider. I don't know if for people, for example, leveraging like a pod identity, sometimes what the attacker will try to do is to perform like a SSRF attack. That means they will try to pull the information from the metadata endpoint of the node and extract all this information. For example, if you're in AWS and you have an IAM role associated to this node, after that, they will usurp this identity and they will try to continue and to perform lateral movement.
right. Thank you very much, Max.
You're welcome. Thank you.
Thank you.
1, 2. Okay. So you're hearing me? All right. So thanks for joining this talk. This talk is about how we can push the boundaries of multi-tenancy, like going outside of namespaces, network policies, and seccomps that we used to have, but extended to also have a better consolidation on the workload that we have on our clusters. Briefly, let me introduce myself. So I'm Rashid. So I'm a contractor. 7sphere is my own company, a huge company of one, basically. So I've been in the IT for a couple of years, doing a lot of stuff around DevOps, DevSecOps, observability, and actually working right now in a project that is kind of close to what I will talk about. If you want to reach out after this talk by email, LinkedIn, Twitter, X, blah, 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 wherever you find Zinity, you have most of the chances that it will be me. So reach out to me if you have any questions. Daily, what I do, I play with a lot of stuff, like really, really a lot of stuff around security, observability, containers, CI/CD, automation. And I really love it. Since a couple of years now, I'm also moving to the AI stuff, more like in the platform level. So how can we use Kubernetes to provide the almost perfect AI platform for my customers? Speak about multi-tenancy to my clients. This is how this is it. Like I have my own cluster and I'm just putting in the same namespace, and most of the time default one, all the apps at once. And that's multi-tenancy for them, meaning I have my apps and it works. In fact, multi-tenancy has, we can see multi-tenancy as different levels. If we go into what I call the light, multi-tenancy is more about using namespaces and all the features around. Network policies, RBAC, limits, resources, security context, everything that allows each and every application to be as secure as possible, but also as segregated as possible, meaning we really want to make sure that each application could not discuss, talk, have a network connection with the other. Especially if you remember the talk from Maxim, this is exactly what we want to avoid, like really escaping the whole thing. If we want to move a little bit higher, we probably want also to have dedicated resources. And that's a way of offering another level of multi-tenancy. So we will dedicate some nodes to the applications, and each and every node will be probably separating because some of you will want to deploy Postgres database on your Kubernetes cluster. Why not? And then you will want to have dedicated nodes. You would want to have several nodes for the security components or the observability, just to make sure that each and any application has the amount of resources, but also the appropriate level of security that it deserves without jumping into another. We can go a little bit higher. But before that, and before going into some outside stuff, what I want to highlight is multi-tenancy in Kubernetes doesn't necessarily mean external components, add-ons, admission controllers, plugins, whatever. Kubernetes in itself offer most of the features that we want to leverage to have a proper multi-tenancy. We had a talk this morning from the Edera talks at the back. That spoiled a little bit of my talk, but that's fine. And this is exactly what they discussed. Like, multi-tenancy is a thing, separating application is a thing, and you don't need to at first go into, oh, I want to use this all shiny new admission controller that someone talked to me about because this will be the perfect solution to secure my app. Just use the default security features like RBAC, quota, priority classes, taints, tolerance, security contexts. Everything is baked in. And if you really want to go a little bit higher, you might probably want to leverage virtual clusters, like vCluster, for example. So you will want to use this physical cluster that you have with virtual clusters. And in each of those virtual clusters, you will have namespaces. And for all of those namespaces, then you will have all the features that you want to use. And if you want to go a little bit higher, you can mix that all up. Like, you can really have everything at the same place. So you have your physical cluster. Your physical cluster will host virtual clusters. Those virtual clusters will be hosted on dedicated nodes. These dedicated nodes will be dedicated to a separate application, and this application will be then separated from the other with namespaces and stuff. This is, again, easy to achieve, kind of. But that's also a way to avoid cluster sprawl. Like, I want to have a separate cluster for observability, for my CI/CD, for my institutional website, the CRM application, blah, 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 blah. You can literally consolidate. Is this maintainable in the long run? Yeah. Is this easy to debug when you have some issues? Not really, especially because, as you can see here, we are literally piling up, especially at the network level. We are piling several network layers, all of the others. So it gets tedious, but that's fine. One issue that we have here is we're still using a single container runtime, the default one, which could be Containerize, or if you're into OpenShift, you might already using Cryo. But we are using a single container runtime. What if we can have the whole stack, and now in these virtual clusters, we will then add more container runtimes side by side. Let's say, for example, that you have your institutional website. Container is fine. But at some point, someone wants to use a gvisor or Kata container to have a better isolation. And the first step would be then to create another cluster. But perhaps, and this is what I will try to convince you, perhaps we can have both of them in the same cluster, in the same virtual cluster, for the single nodes, for each and any nodes that is related to the application, embedded into the last one. This is also when I was starting to work on this talk and have a kind of discussion internally with some friends. This is exactly how they react. Like, what the hell are you talking about? This is nonsense. But actually, if we go back in history at first, so the very first Kubernetes releases were based with the Docker daemon, and then it evolved and so on and so forth, and then Containerd became a thing, and then it has been donated to the CNCF, and then Kata container finally was being announced, and that allows us at the time to have more container runtime born and available. gvisor, Google Kata container, Firecracker if you're in AWS, and so on and so forth. This has, let's say, one or two major moves. The first is the Docker daemon has been separated from Kubernetes, starting the 1.20, and removed completely in 1.24. We made this move especially because during the Kubernetes lifecycle, we end up with having kubelet, Docker shim, Docker daemon, Containerd, and then the appropriate runtime, which wasn't really necessary because we can easily go into kubelet, Containerd, your shim interface, and whatever the runtime you want to use. To summarize for now and give a broader view, depending on, for example, and this is the example here for a security aspect, you can use Containerd, which is the default. If you want to go a little bit higher, then probably want to use gvisor, which has syscall isolations. Going a little bit higher, you can then use Kata container. And if you really, really want to have like the full virtualization into your Kubernetes cluster, then go into KubeVirt. And what I will try to show you is we can have everything at once in the same cluster. One issue at that time is, so before Containerd went into v2.0, if I remember correctly, we had to drain the node, start the kubelet, install the old runtime, deploy the new one, and so on and so forth. Basically, what it means is literally shut down each and every node, do the upgrade, install the new container runtime, and then restart everything, which was bit risky. You had also some downtimes. There was issue because at some point some container runtimes has some, how do I say, we're a little bit picky regarding the operating system that you were using and so on and so forth. Thanks to the evolution of Containerd, we now have just a couple of things to do. We don't need to shut down the node. We just need to install some binaries, put some configurations files into the appropriate location, install the runtime class, and boom, that's it. Don't restart your nodes, not necessary. Don't drain. Just install the new container runtime, create the appropriate runtime class, use it by using the appropriate label, and that's it. That's basically it. Again, this interface now allows us to choose the container runtime that we want to use. It doesn't mean that you have to ditch Containerd. It still tells you that you still can use Containerd for the default application, but side by side, you can then now use gvisor and kata container and firecracker and so on and so forth if you want to play with it. Just a little bit of a word is adding more and more container runtime in the same cluster is fun. Works. I'll try to show you. But it also adds more complexity in the long run. Like, oh, this application had issue. Oh yeah, but what is the container runtime for this application? It's gvisor. Why have we chosen gvisor? Oh, I can't remember. And why have we then not used Containerd and so on and so forth? So just be cautious because this is really interesting in a way that you can literally choose, and even with the full virtualization, for example, use Windows OS at some point, can work. But in the long run, in your day two, this is a nightmare. This project is not in, well, the part of this project, which this talk is based on, is not yet in production, but it's already a nightmare for me. So just saying. Let's go a little bit deeper now. So we have Containerd, we have Firecracker, gvisor, kata container, but we're still using containers. What if we can now use container and virtual machines side by side in the same cluster? KubeVirt allows us to do that, and KubeVirt allows us to have this mechanism. We had, again, the talk from Idra that spoiled a little bit about this, so I'll just skip that for now. But the overall idea is, okay, I have legacy application that I want to run into my Kubernetes cluster. I can't move them into container for whatever the reason, but the other services that I want to leverage for this application runs in container, and this is where KubeVirt really helps. You don't have to have your Kubernetes cluster with your containerized application at some point, and then your full virtual machine into Proxmox, then VMware, blah, 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 somewhere else. Again, you're using the same cluster with everything at once at the same place. How does this KubeVirt works? This tells a little bit about it. Very simply, so we have a controller. This controller deploys handlers as a daemon set on each and every node that has been tagged to be hosting virtual machine. And each virtual machine is managed by this Virt launcher pod, which underneath leverages libvirt, which then calls QEMU KVM, sorry, to boot up the full-fledged virtual machine. So again, the physical cluster with virtual clusters, with dedicated nodes, with separated namespaces, with all these security features that you want to play with the different container runtimes, fun, and now add your shiny, well, not so shiny anyway, your more, how can I say, disturbing Windows system that you want to play with, and that someone tells you, hey, I don't want to keep this, just please move them. This allows us to do that. Again, works in production, can't. Just bear in mind that this only works on modern CPU with nested virtualization features enabled, And even with that, I had some weird behaviors. So don't think about, oh, I have these old servers that are literally dying over there, and I want to use them for my project. Just bear in mind that all these features are, for most of them, out of the box from Kubernetes, aside of the Kubert stuff, but still leverages and requests you to use modern CPU that has those virtualization features baked in, or you will face some trouble. How about a quick demo? Has anyone burned yet a candle? No. Okay. Actually, I did. No, I'm kidding. So, as you probably saw until now, I really like to play with weird stuff. Yes. And go out of the edges. Yes. So this is a virtual machine on Azure where I deployed a, let's see, come on, a Kine cluster. So I have virtual machine with my Kine cluster running, and I have some shiny pods. For the sake of the demo, I just prepared some stuff. For example, Kata container, which is lives here as a pod, is a daemon set. And this daemon set is very useful because it prepares automatically for you in each and every node that has been correctly tagged everything that you need to run Kata container. What it does, just to show you, if I go a little bit back, install, where are you? There we are. So it copies some files into the host system or into the Docker container, in my case. Figures all the runtime classes that the Kata containers offers. And so you can see Dragon Ball, QEMU, confidential computing. There's also TDX, GPU if you want to play with AI and stuff. And in the end, it says, okay, I finished. So this is obviously a privileged mode, but it has done everything for me. So all the manual operation that I would need to do to deploy Kata container has been done for me automatically by this Kata deploy daemon set. What it does, if I just do this. So think about this container as a full-fledged node. It's the containerd config. And if I look, for example, here, it has added automatically a configuration to tells me that this Kata container now is managed by containerd as a plugin and uses this file. And this file has all the configuration for all the runtime classes that I want to use. And for all of them, I have, again, a specific configuration file that tells me which binary I should use and so on and so forth. Everything that has been done for me. So now that this has been prepared, I want to look at the runtime classes that now I have available. So if I go into runtime classes, kubectl get runtime classes, I have plenty of them. 3 hours, as I said, prepared a little bit of stuff. For each and any runtime classes, this is linked to the containerd plugin interface, the Kata container configuration file that tells exactly which binary I want to use. If I show you, like, if I was in a full-fledged node, if you look here at the top, I have my containerd with runc, which is the default one. And if you look down below, this is my Kata. And my Kata one is managed by containerd as a plugin. And I can do the same if I want to play with gvisor or Firecracker or whatever.
I told you before that I can also add now virtual machines. So let's see if I have some virtual machines. Get virtual machines -a. Ubuntu. If you want to run virtual machines into your Kubernetes cluster, I highly advise you to use the virt-ctl kubectl plugin that you can install, and that allows you to use the virt-ctl command with kubectl command as you do with your default cluster without switching. For example, this virtual machine seems to be in Ubuntu, it seems to be running, so I can do this. And if I'm lucky, I should be on a Ubuntu system. Let's see. Let's do some logout. Ubuntu. Do this in production. Come on. I told you I'm playing. Well, actually, you saw it briefly, but I just wanted to show you the full the full message of the day that says blah, 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 you're into Ubuntu. Ah, there we are. So I'm using a virtual machine, and this virtual machine runs into my Kubernetes cluster. What's funny here is we live in a Kubernetes world, and this is a Kubernetes cluster. That means that my virtual machine is, where is it? Oh, that's the fun. That's the fun part. Will I be able to get out? Let's see. No. Yeah. Okay. Ubuntu VM less machine would be nice. This is an image. So this is an artifact that I use as whatever the container that you want to play with, but it's a virtual machine, and I can add a cloud in it as a full-fledged Linux virtual machine to configure. And as you see it, I just said, oh, the Ubuntu user has as password Ubuntu. So that allows me to do everything in the same cluster. What's only missing here, because I really didn't want it to go that far. If I had 15 minutes, I would have to probably, but not now, is to do all this demo into a virtual cluster that lives into a physical one, just for the sake of the demo. So pros and cons. Workload security, very high. Cost optimization, try to do better. Performance optimization, depends on the runtime you're using, but most of the time it's really, really fast. Again, this allows you to play with whatever the container runtime you want to use. If the security team has some concerns about, oh, containerd is probably not the best container runtime as a security level, then now you have some options to offer. This is the good side. The bad side is, as I said, in the long run, it's get tedious to manage, update, because now you don't have a single containerd, which is part of the default Kubernetes cluster and distribution. Now you have to manage your Kubernetes distribution and all this container runtime that you have chosen to play with, and the kube and the virtual machine. Very complex when there's a lot of issue, especially at the network level. Just as an example, in this demo, we are piling up something close to 10-ish levels of network, all different with their own subnets and so on and so forth. And now you have your application that dies. Be my guest, try to find out easily if it's the runtime, the Kubernetes cluster, the VM. VM are fine, but these are VMs. And by VMs, I mean full-fledged operating system. Windows or Linux or whatever the system that is managed. Huge. It's a lot of memory for nothing. Cautious. One last thing about this is be very, very strict, picky, cautious, pro, whatever you want to call it, and train your team. If you build this in production, I'm trying it. So well, let's see if we see each other probably in a year. I might give you some fun insight, but just if you want to go down this road, which I get it could be a little bit challenging, please train your team. This is fun. You can really do a lot of stuff in the same cluster and use all of those very cool features. But in the long run, if your team hasn't been trained, you're in jeopardy, your production in jeopardy, and what could be a 5 minutes debug could end up in days. That's it for me. I think I'm right on time. If you can send some feedback, please. I'm really, really eager to get some feedbacks. And if you have any question, then that's the right time for that.
And we do have time for some questions if anybody has one.
Hello. Has anyone actually requested you to build such a cluster? And why?
Unofficially, yes. I'm saying unofficially, yes. Why? Because there's some companies that want to go into Kubernetes, but have a huge amount of legacy and a very strict security teams that thinks that Kubernetes can be the legacy system that they have without changing anything, and looks for solutions. And at some point, I probably made a mistake, I think, that day when I said oh, we have runtime classes, we can play with it. And just someone was in the room and said, okay, do it. That's how it started. I don't know how it will end, to be completely honest with you. I have to say it unofficially. But for now, at least for me, I like it because it's a highly technical topic, and I like it. There's a tons of challenges, and that's my fuel, basically. So, and I'm paid for that, which is cool.
Any other questions? All right, thank you very much. talking about building your own Cosmos. Welcome.
Next topic. Maybe it's on now. All right, now it's on. All right, cool. All right, welcome everyone to building your own Cosmos, how to take control over the control plane. This was a title that I made because it sounded cool, which is kind of what I do. I make cool titles for stuff and then I try to fill it with content afterwards. But what we're going to talk today is we're going to talk about Cosmotron. So it's the project is not called Cosmos. I got that question earlier. That's why I'm saying that. So if we start off by, there you go.
Hey, I'm Jussi. I've probably seen many of you in these events already, but yeah, I lead the K0's CNCF Cube distro development at Mirantis, and also one of the projects that we do is this Cosmotron. So that's what we're gonna show today.
And my name is Robert, and I work at Superstereo based out of Norway. I do a lot of things. I keep on saying yes to things, which is well, not a problem, but you know, I get pretty busy. I'm a CNCF ambassador, been in Tag App Delivery, which unfortunately now doesn't exist, but you know, go us. We were great. And I've been in the CNCF for many years. Started off with the helping writing the GitOps principles, and since then just kind of like been part of a lot of things. So I came to K0s because I found the project itself very interesting, and I had some free time. So I started butting into the meetings there, and now I'm going to speak about it. So sure. So. What we're talking about today is the control plane. And for many of you, I'm guessing, the control plane is kind of like this abstraction thing that happens in a cloud provider, more or less, because usually you don't really, unless you host it, the vanilla Kubernetes, that's the control plane itself is kind of something that you don't really think so much about, because you either go to Amazon, Azure, or Google and say, give me a Kubernetes cluster. And then something happens in the background. So whenever something is abstracted away because they need to take care of it, it's usually one of those things where it's a very complicated thing, right? But it's not really. It's only a couple of processes. You have some components. You have the Kube API server, so you can actually connect and do stuff in Kubernetes. You have the controller manager, which manages controllers. I love the naming of these things. And then you have the cloud controller manager, which it controls the cloud. So resources there. And you have a scheduler, which kind of like puts stuff places, find out where there's room. That's kind of what we do with Kubernetes, right? And then it's stored in a database. And that's about it. And Kubernetes is often referred to as a very difficult and complex topic, but honestly, it's just the same process that we've been doing all along, just in a package. And the control plane is part of the package. So why would you decouple the control plane? Well, like I said, the public cloud hyperscalers have been doing this for a while. This is how they give you the managed services. And what they have done is basically just taking these few processes and put it somewhere else, and then tie it together so that what you care about is the worker nodes and where your stuff is running, where your applications are running, and you can take control of that in a less things to take care of basically. So this is a screenshot of nodes in control plane in EKS, I guess. And as you can see, the roles for these nodes are none, because they're not doing anything except having these very specific things on it. Yeah.
Right. So, like mentioned, hyperscalers have been doing this for ages already, basically since, as far as I know, since the inception of like EKS and AKS and all those things. So the reasons why they do it is that they can really separate the concerns. You as a user don't care, you don't see the control plane, it's hands off for you, and for a good reason. Cost savings, maybe not. I mean, at least on an operational point of view, it does save a lot of cost for you when you use things like EKS. You don't care about etcd, you don't care about API server, you don't care about compacting etcd and those sort of details, right? It also gives you architectural flexibility. Now your control plane is separated from the actual workload cluster, right? So which actually means if we're clever how we set up things on a control plane, you could run the worker nodes in your basement, although the control plane might be on Amazon or Azure or whatever. And especially for edge-like setups, that's super useful. If we are clever how and where we run the control plane separated from the actual workload cluster, we get operational simplicity, kind of from pets to cattle mantra. Whether that's a good naming of things or not, that's a different discussion. And then what we've seen in the K0s and Cosmotron community is that people struggle with multi-tenancy with Kubernetes. I guess we all know that a cluster as such is not a multi-tenant thing. Don't try to make it multi-tenant because it is not. So that's my advice. Don't even try, right? So the bad side of things, of course, is that now the network, the wide area network between my controllers and workers is actually part of the control loop. So if the networking breaks, you lose control. You don't lose the cluster, but you lose control of things. Blast radius, well, if you host your control planes in some infrastructure, some way now, it could be a Kubernetes cluster, which we'll get into soon. Your infrastructure where you host these control planes, that's kind of like a single point of failure in a way. So if something super bad happens, you might lose like 100 control planes at once. But of course, that's like something you can mitigate with good design and good infrastructure and availability models and whatnot. One other thing that we've seen in our community is that people seem to kind of I don't know how to say it, kind of this model pushes away some folks at least, because it's not the kind of vanilla way of Kubernetes where you have control plane nodes labeled as control plane nodes and then these non-labeled nodes for workers. So it's kind of foreign pattern for some people for reasons which I don't get, but that's a different discussion again.
All right.
All right. So, like I mentioned, if we're clever about how do we configure the controllers. Thanks. So if we're clever, how do we configure the control planes and the Kubernetes components? We can actually separate these two planes together or from each other. So in K0s and actually in many of the cloud providers too, they use a component called connectivity. That lives actually in a repo called SIG API Server Network Proxy. Don't ask me about that name, but it's known as connectivity in all the other places, basically. So what connectivity actually does is that you deploy or you run a connectivity server next to the controllers, basically usually on the same node where you run the control plane components, and then you run an agent on the worker nodes. The agent calls home to the connectivity server, basically to the control plane, and it opens up a TLS tunnel. think of it as a kind of like a reverse SSH tunnel, which probably many or most of you have used in the past at least. It's conceptually very, very similar. Now, when API server, for example, has to call to kubelet, when you do kubectl exec, kubectl logs, and port forwards and whatnot, API server actually calls kubelet's API to do that stuff. API server actually is configured now to use this connectivity server as proxy of sorts in a way. And then the data actually goes through this reverse tunnel. The beauty of this is that it's the connectivity agent opening the tunnel. So now you can actually have layers of firewalls, layers of NAT, and whatever in the network. And as long as you can open a TLS connection, call home, everything just works. I've literally tested this setup in a way where I had my control plane running on Amazon and my worker node running as a VM on my MacBook while I was flying over Greenland. And it actually works. And that's one thing where this pattern also kind of shines, that it tolerates a lot of latency. I've been able to test like +1 second latencies, 35% packet loss, and it still works.
All right, so we're talking about Cosmotron, but it comes out of the project KCRS. KCRS is the zero stands for zero dependencies, zero requirements. So I don't know the mantra by heart by now, but yep, thank you. And the idea is that you have a single binary and you run it, and then you have Kubernetes, basically. And so it works in already in the couple modes. So this kind of just again lends into the idea of hosting your own control plane, because that's kind of what KCRS is doing already. And it supports not only etcd as a data store, but others as well. But like I said, we're talking about Cosmotron, which is a sub-project under KCRS where we host our own control plane. And what happens is that, what you do is that you have a controller for Cosmotron, which then spins up your control plane as pods and things that you know of. So there's no difference in managing a control plane in regards towards like applications and the other things that you already are managing on Kubernetes. And besides that, like you see here, it's just using all the normal Kubernetes concepts, and through connectivity, you can connect to various workers, which can be in different clouds everywhere. But that's the Cosmotron out-of-the-box experience. You also have Cosmotron plus Cluster API. So utilizing Cluster API, so it can spin up the various resources that is required otherwise, and have the entire process be managed through well, you can manage it through GitOps, because everything's declarative, everything's config, everything can be stored in Git, yeah.
And I think that's the main point of Cosmotron and running control planes as pods is not, well, of course it's cool and everything, but the main point is that now you have the exact same operational model for your control planes as you have for any other workload that you run in your clusters, right? Which also means that we have the exact same luxury of Kubernetes doing a lot of things for us, like self-healing and all that stuff. If one of the nodes running one control plane pod dies, it'll eventually move to some other node. You have kubectl scale, and boom, you have more control plane instances.
I don't know if you want to speak to this because you generated it.
Yeah. Emphasis on the word generated it. Yes. So it's way too busy. The point was that now we're running control planes via a declarative set of resources, right? Like mentioned, Cosmotron can also work with Cluster API, which provides the kind of full stack of declarative way of managing things, all the way from high-level cluster abstractions, all the way to Amazon or Azure or whatever infra-specific machines. So you actually can do now GitOps on kind of 3 different levels. Of course, you can do GitOps on the management cluster, defining that which controllers we're running, what's running in the management cluster as a workload. The second layer is the clusters, that what we usually call child clusters or workload clusters. Because everything for those clusters is now declarative. So I can use GitOps patterns for that. Whether you use Flux, Argo, whatever, it doesn't matter. It's the pattern that matters always. And then the third level being the child clusters. Of course, now you're running N+1 clusters, so you definitely need to run GitOps for those. You're not gonna manage 100 and plus clusters manually. kubectl, do this, do that. No, please don't even try. One of the things that I've seen people starting to do in general, not only with Cosmotron and hosted control planes, is a pattern where they actually run these GitOps controllers in the management cluster. So each of the child clusters you create actually gets a GitOps controller running in the management cluster. So it's kind of like a pull and push combined model in a way. But it's options.
And I have a demo, which for some of you who talked to me today know that I've been struggling with. So it is what it is. We'll get to that later. So just quick show of hand, who here is familiar with GitOps and how Flux works and stuff like that? All right, so yeah, I was thinking of like, do I need to go through these things at this point? Yeah, you need it. Yeah, yeah. You don't need an introduction, or do you? Yeah, you should probably know by now, right? But really quickly, there's 2 specific things that kind of makes this work. You have the source controller, which looks at the source, pulls that down. And then you have the customized controller, which kind of makes it happen. So you define what you want to apply, point it towards the right direction and how often it should do so. And then it should happen on your cluster. It's magic. Should read up on it if you haven't. But so currently, I'm in a Azure Kubernetes cluster. I just need to think because I was using my external keyboard and now I'm not. And I have Flux installed, like I said, but we have a couple of things going on. We have our, well, if it works, there we go, Cosmotron itself. So we install the Cosmotron Control Manager, which is running as a pod in your cluster. But more importantly, what I have defined, I'm going to go a little bit off script, sorry, is these 2 sets of resources. So just making sure you can see it. You have your Cosmotron control plane, which well, basically defines the control plane. So again, naming in Kubernetes world is great. So by defining what versions you have and a little bit about like what type of what port you're going to use for the API server and connectivity, it spins up and hosts the control plane itself. It also spins up the, in this case, it's the data store because we haven't defined anything else, but we could potentially have other databases to store if we want to. It can be also be external and basically do whatever you want. And then we have the cluster, which kind of just defines this, the actual cluster of things. And if I go back into my management cluster and press 2, we should see you have the 2 pods. So you have your control plane pod, which runs all these various processes, and then the etcd, so the storing of stuff is there. But one thing we can look at, what was the first thing we're going to look at? What was the first thing we're going to look at? We're going to look at the, not secrets, but service, sorry.
Service, yeah.
Thank you. Only been doing this for like hours, so sorry. We have our control plane service set up, and it's set up as a load balancer, so it's available online. And as you can see here, you have 2 ports, the ports for the API and the connectivity server. So this is kind of the entrance way. So everything needs to be able to reach this, obviously. And if you want to connect, there are secrets here. For instance, the kube config and everything that you need to do all the various processes. What I wanted to do is to use Cluster API to spin up and join nodes, but we don't have time to go into why it didn't work. So like if you set it up correctly, it's going to work. Just imagine that. But what we can do now, because we actually have the control plane running somewhere, I downloaded the kube config to my computer. And what we can do is run K9s again using that kube config, and it should work. No, emphasis on should. And as you can see up here, we are now on the cluster control plane K0s. And if I look at, well, if I look at nodes, I'm not going to see anything. We're at nodes now. But if I look at pods, we can see that we have CoreDNS and the metric server running. It's not up and operational because I don't have any worker nodes. That is a long story. But again, so this is running as pods on my cluster and ready to join machines.
Yeah,
more or less.
And exactly like we've been discussing, now you could actually join the worker nodes from whatever infrastructure you want.
Yes.
It doesn't have to be the same as your infra. It could be Amazon, it could be Raspberry Pis on your Pocket or whatever.
Yeah.
Some of the use cases where the community has seen this pattern as super useful is, well, obviously Edge. On Edge, you don't usually have the resources even to run the control plane stuff, because we all know etcd and kube API server together, they'll eat up whatever you can throw at them. The AI factories, AI infrastructure is something that this is becoming more and more popular. And that's because of the fact that if you think about the AI machines, they are super huge, monstrous compute nodes. And there's a lot of like GPU cards and networking stuff and whatever attached, which actually makes it super hard to operate in a way. Even a reboot takes like 30 plus minutes. So you can't easily do like rolling upgrades. And then again, if you have like super big GPU enabled nodes on your basement, do you really want to waste those nodes for control plane nodes? Probably not. And then of course the multi-tenancy part. Now you have like Kubernetes in Kubernetes is kind of like Kubernetes as a service way. So you can actually do multi-tenancy now, because each of the control planes are fully isolated from each other. Each of the clusters have their own workers.
Yeah, and if you work at someone who does managed services, this is obviously a good thing. But it also can be, for instance, if you have a workers that are running on in pipelines and such. Like if you can control the control plane and just join all these worker pipeline nodes into that, you have more control over what's going on. Don't have to use public's runners and so on and so forth. So there's a lot of different opportunities to use this. Again, it's the sky's the limit or something.
So just quick summary, Cosmotron, of course, open source, part of the CNCF K0's family, decorative control plane management. We get lightweight foundation with the K0 distro itself, which is kind of that enables everything. Decoupling. And then when you combine things with cluster API, then that's where things get interesting and challenging at the same time. And then GitOps all the way for every single layer of the stack.
Which should be a mantra by now for everyone. So,
yep.
I'm just saying, I'm not biased or anything. And that's about it. Thank you.
We do have a couple minutes for questions. If anybody has any questions. We got that mic. You guys can share this one.
As a developer, GitOps is indeed something I want, but I'm not always in control of my platform. So how does this scale up against something like SUSE Rancher or other alternatives that make use of cluster API?
So I usually say it like this, that what makes it different, this Cosmotron approach different, is the hosted control plane. So we actually run the control planes within the management cluster. So it's really kind of like Kubernetes in Kubernetes. So it gives you a lot of operational benefits. It doesn't, of course, it's not a silver bullet. So you shouldn't use it blindly for every single use case. There are definitely use cases where you should run things the normal way of actually having like 3 VMs for controller nodes and whatnot, which is actually something that Cosmotron also supports. The default model and where Cosmotron was born is this hosted control plane model.
Thank you again.
Thanks.
Great work. Our next presentation is Uncovered the Hard Truth About OTel's Vendor Neutrality with Adriana Villela and Josh Lee. Hey, everybody.
Hello. Thanks for staying.
Yeah, we appreciate you. Okay, so we're going to talk about vendor neutrality in
we are.
OpenTelemetry.
Yes. And it all started last year, right? Last year?
Yeah.
Because Josh posted this on LinkedIn about OTel vendor neutrality. And I remember reading it and I thought, well, I want to write a response to that, but I need to noodle on it a bit. And then I wrote a blog post in response to it.
Like you do.
As one does. And because it didn't really require, like, it wasn't a LinkedIn comment length response. Anyway, then we got to talking. We're like, hey, it's CFP season. We should write something together. Can we expand on this post and my LinkedIn post? And well, here we are.
Yeah.
So yeah, and I guess the first thing to start off with is standardization. Good. We love standards. For example, my favorite standard, if you're of a certain age, you probably remember whenever you got a new cell phone, and even if it was the same manufacturer, you'd get a new friggin' charging cable every single time. So then you'd end up with a collection of charging cables in your desk drawer. That was super fun. How about you, Josh? What was your favorite?
Well, I am like just now getting on the USB-C bandwagon, and I'm kind of a big fan of only having one cable for everything.
Yes,
Yeah.
yes,
Yeah, it's pretty great.
absolutely. Folks here in the audience, what's your favorite standard? Shout your favorite standard. Yes.
IPv4, that's a great one. Others, it doesn't have to be related to tech either. IPv6, I
Good
haven't
one.
gotten there yet. McDonald's came up another time we gave this talk.
Yes. Woo, big
ISO
fan.
everything, right? Like
That's
just
right.
ISO. Okay.
Well, thanks for participating. You know what's a standard we also love?
OpenTelemetry.
Absolutely. And why do we love OpenTelemetry, Josh?
Well, I mean, it did standardize a lot of things, right? We got standardized instrumentation. That's awesome. We got standardized pipelines in the form of the OpenTelemetry collector. That's awesome. The project very, very explicitly does not include anything for that last box over there, right? No backends, no storage, no UI. It's just a pipeline, and that's explicit. So let's talk about that a little bit.
Yes, but first, let us introduce ourselves. My name is Adriana Villela. I am from Toronto, Canada, originally born in Rio de Janeiro, Brazil. I am a CNCF ambassador, blogger, podcaster, maintainer of the OTel end user SIG, and newly minted OTel community manager alongside my girls, Reese Lee and Julia Morgado. By day, I am a principal developer advocate at Dynatrace doing all things OTel and observability. By night, I climb walls. I went to the bouldering gym this morning, actually. And I also love capybaras because they make me happy.
I mean, who doesn't love capybaras? I'm Josh Lee. I am an open source advocate at Altinity. We do stuff with ClickHouse. So if that's interesting to you, come talk to me. And I try to keep up with Adriana sometimes. It's tough.
He can't keep up with my energy. Well, so I guess we should get started. And the first thing we want to cover is this.
Yes. So people sometimes ask me, like, why does OpenTelemetry exist? I've even seen some LinkedIn posts about this recently saying, like, oh, well, it was made by the vendors, or, oh, it was forced by the customers on the vendors. I disagree with both of those. I think OpenTelemetry exists because of distributed tracing, right? Yes. Yeah. Well, Jaeger is cool. Yes. But there was a problem, right? So, like, if we think about logging and metrics, we needed some kind of universal open standard, right? Because we want to be able to just consume this with anything. But logs are just like text and some labels, and metrics are just a number and some labels. So they're not really that complicated of a thing to create a standard around. And we had pretty good standards, right? We have Journal D, we had Stats D, we have Prometheus. And so this was largely a solved problem of openness in observability. But then you get to distributed tracing, and it's like, well, now we actually need the services to talk to each other. And they need to understand a little bit of the context from the service that came before them and the service that comes after them. And we need some kind of transport for moving that all around, right? So it gets a lot more complicated. And the first solution to this, oh, I'm getting ahead of myself. Yeah, there we go. Right. So this is what I'm talking about. So we needed open data formats, right? And we needed distributed tracing because of distributed computing, right? We all have our computing happening in many, many places now. So a single log is no longer, a single stack trace is no longer really that helpful. The vendors solved that problem, right? Vendors gave us awesome tracing libraries, but that required then putting the vendor's code into our code artifacts, which is like fine if you're small, but then like, let's say you're another vendor and you're providing your code artifacts to your customers, right? Like then which vendor do you choose? And then you're forcing that on your customers. So yeah, OpenTelemetry solves this in a vendor neutral way that also allows like people like Amazon to give you instrumentation out of the box that you can use with any vendor. And that's really awesome.
But what makes OpenTelemetry vendor neutral? At a high level, it means that if you decide you want to break up with your observability vendor, you don't have to go in and rewrite your application instrumentation. So that's a huge bonus, because in the olden days, if you hated your instrumentation vendor, well, guess what? You're stuck with them, because otherwise you would have to re-instrument your entire app, which is a big feat unto itself, because instrumentation is code. It's code that can break, so that adds a fair bit of overhead to your projects. Now, what specifically is vendor neutral about OpenTelemetry? Well, we've got these lovely components. We have semantic conventions, the API and SDK, OTLP, and the OTel collector, and I'll dig into each of these in a sec. So semantic conventions, basically think of them as the standard labels that we use for our telemetry. And it's similar to what we have over here with our food products, right? We have ingredient lists. They are standardized ingredient lists. We see the same format, contains fats and sugars and carbohydrates. And that's basically what semantic conventions are for OpenTelemetry. We also have the OTel API. Now, the OTel API, it defines the methods used to instrument your applications, and it serves as the entry point for telemetry. And each language in OTel has its own API.
Or, as I like to say, it's just the buttons that you push to make telemetry.
Yes. And I should clarify, by the way, it's not they have their own API, it's their own API implementation, because the API is standard across the board. Also, we have the OTel SDK. Now, if the API was the what, the SDK is the how. So it implements the API and determines how the telemetry is generated and correlated. And the cool thing about the SDK is because it's an implementation of the API. It means that, yes, there is the, your upstream OTel SDK, which is awesome, but you could also write your own SDK, or a vendor could have its own SDK. And that means that because as long as those SDKs implement the API, you can swap those around. So that means that, you started out with the official OTel SDK, awesome, but you've changed your mind, you want a little something extra, you write your own, great, you can swap that out, it's not going to break your code. And if you're not ready to make a commitment to which SDK you want to use, no problem, because there is a base implementation of the SDK from the OTel API. So it basically means that your code won't break if you haven't decided yet which SDK you want to use. But the only thing is, it's not going to emit any actual telemetry. But it gives you a little bit of chance to think, right?
Yeah, this is really awesome, and it enables some really, really advanced use cases. I will say for most of us, probably don't need to think about this too much. We can just use the standard SDK, which comes with the OTLP exporter out of the box, which you should probably use.
Yes. And speaking of OTLP, this is probably what we consider the OTel secret sauce, because this is the transport mechanism for OpenTelemetry. It's the format in which the OTel data it encompasses, it's the data format for the OTel data. And an interesting thing about OTLP is that when OpenTelemetry started a while back, each observability backend had, they didn't support OTLP. Instead, you needed a special exporter that converted from OTLP to that backend's own proprietary format. But what we've seen in the last few years is that many observability backends have actually adopted ingesting OTLP natively, which is huge. And it means that these vendors are taking OpenTelemetry seriously. And we've seen recent ones like Prometheus and Zipkin, and Jaeger, for example, among others.
Yeah. And really, when you think about this, if we combine the semantic conventions with OTLP and OTLP compatible tools, we have achieved interoperability, which we're going to talk about in a minute. And then if we add in the collector, we also get multicasting, which we're also going to talk about in a minute.
Yes, a good segue into the collector. Collector, other favorite component of OpenTelemetry, the Swiss Army knife of OTel. This is my own Swiss Army knife. It is a vendor-neutral binary used to ingest data from multiple sources, used to transform data, and then to send that data to one or more destinations. And as Josh said, it gives us on interoperability, and specifically
Interoperability all the time.
yes, all the
Right?
time.
Like, so I think the vendor neutrality, this is like one of the big lies of OpenTelemetry to me, is that vendor neutrality is sold as this way that you could change vendors. But like, who wants to do that? Even with OpenTelemetry, this is a months or years long process for many organizations. But what is awesome about vendor neutrality is that I can use all the tools that I like together at the same time, all the time. Everybody gets the flavor they want. That's awesome.
It's true. And who doesn't want all the flavors? So what are some examples of this interoperability? Well, for example, we have one or more tools for all the signals. So for example, you could have
I think we might have to both hit the button. Wait, yeah.
Oh, yeah, I think we
So
did.
skipped one.
Sorry. I was like, that doesn't look like it's in the right order.
So this is the common way that you would probably see OpenTelemetry, right? With certain stacks that have a different data store for each signal, or you're using a different tool for each signal. And you send all your telemetry to the OpenTelemetry collector, and then it sends the appropriate signal to the appropriate backend. But there are so many more things that you can do with this, which we almost got to.
Yes. Like, for example, say you have, we do see a very common use case where like each signal is sent to a different tool that specializes in that. But what if you have a vendor that does all the things? Amazing. You can send all of your signals to that one vendor and that's it. But maybe you're not sure you're between vendor A and vendor B. No problem, because you can send your telemetry to both vendor A and vendor B at the same time. And so you end up with this lovely bake-off between vendors so that you can determine, okay, which one does things better in the way that I would want them done.
Yeah. And don't do this long term, because they are both going to charge you for storage. So like, you can have two cakes, or you can have your cake and eat it too, but you're going to pay for two cakes.
That's true.
All right, but let's say we want to do something more permanent, and like, let's say our organization has a requirement, a legal requirement, to keep all logs for 7 years. I've seen this very common, right? If you think about your modern observability vendor, I won't name names, but that would get pretty expensive, right? So what you could do is use the fancy observability vendor for all of your most recent telemetry, give your SREs all the tools that they need for rapid analysis and diagnosis, and for that compliance need, well, ship it somewhere cheaper, like on-term storage, long-term storage, or S3 or something.
And then finally, we have another use case, which is, suppose you are in an organization where they're like, okay, for production, we want you to use this vendor. Awesome. And everyone has to use that vendor. But maybe your devs, they don't have access to that tool, but they should still be observing their own code that they're writing. So maybe the devs have decided, well, I can run some open source tooling on my local machine, in which case then you're sending the same telemetry to two different destinations at the same time. Or there's another use case that Josh and I were talking about where you merge companies. Company A has a standard for observability vendor. Company B has their own standard, and guess what? It's not the same one. Until you figure out who wins out, you're basically sending your telemetry data to two different vendors, and depending on the teams as well, right? Because you're merged, but your companies are merged, but your teams aren't merged. So then you will have like team A from company A sending all their stuff to vendor A, team B from company B sending all their stuff to vendor B.
Yeah, so you can do lots of crazy stuff. It's really cool. Really, it means
that you can have your cake and eat it too. And it is a delicious cake.
It is. Those are donuts, actually, but they still look delicious.
Is there a special type of deliciousness?
We did first give this talk
having
in
your
Poland.
donut and eat it too. Okay, but that's all well and good. So we understand what makes OpenTelemetry vendor neutral, but the problem is what happens when you switch vendors? Because it's not going to be just a lift and shift, if only it were that simple. When it comes to, I would say, your telemetry code, on the most part, it would be a lift and shift. But as soon as you're sending that data to the vendor, things are a little bit different. So what does that look like? Well,
Hey, Adriana.
little bit like-
So we got a really good deal from this other vendor. Can you just like switch everything over? That's like a 1 sprint task, right? Or maybe
my
you
God,
can even have it done by
so
this weekend.
easy. So easy. No, Josh, are you insane?
Just a
No.
manager.
No, it is not a lift and shift thing, unfortunately. Now, why not? Let's look into why. First of all, look and feel. You switch observability vendors. Guess what? They're different. So they're going to have different UIs. You have to get used to the different UIs. Number 2, queries and dashboards. Great. You built out all these wonderful dashboards in your previous vendors. Now you're switching vendors. I am sorry to say you are going to have to do that all over again. And chances are the query language used is different from the one that you were used to with your previous vendor, because vendors don't standardize when it comes to query languages. And then alerts and SLOs. If you built any alerts and SLOs in your previous vendor, well, first of all, does your new one support alerts and SLOs? Well, you have to go to another vendor to support those alerts and SLOs. In any case, you're going to have to rebuild them from scratch. So that is extra effort. And then infrastructure as code. Many vendors have Terraform providers to help with the automation and setup of things like those dashboards and queries. Awesome. All that stuff that you did, all that Terraform that you wrote, down the toilet. There's no lift and shift there, because what's available for vendor A might be different from what's available for vendor B. And so you have to be prepared to rewrite that Terraform code.
Just give it all to an LLM. What could go wrong?
Oops.
Oh,
Josh.
sorry.
This is what happens when you give people 2 clickers. Okay, storage and historical data. That one is a tricky one, because when you switch vendors, as Josh alluded to, there are some compliance requirements for certain organizations. And so when you switch vendors, you have to find out, can I actually export the data from my previous vendor, especially the stuff that I have to keep on hand for compliance reasons, and bring that in to the new vendor? The answer is it kind of depends. Not all vendors would allow for that. And so you might be in a situation where you're actually paying for 2 vendors at the same time for a certain period of time, until that compliance period kind of rolls over and you're no longer beholden to the old vendor. And which is why I would say, if you do have compliance requirements, always make sure that you're sending any data that you have to keep in long term. Send that to a third party, probably hosted on-prem or in the public cloud, but something that is like infrastructure. Yeah, some infrastructure that that belongs to you in some form or other, so that if you again go through that exercise of switching vendors, you're not hating your life and your budget.
Yes. Your accounting department will thank you. Okay. Speaking of open source, let's talk about vendor neutral backends. We said that these don't exist. Within the OpenTelemetry project, this is true, but within the open source world, there are starting to be some solutions, and we can start to cobble together something that kind of looks like an observability platform. So just to like break down the pieces that we need, right? We have this instrumentation that's covered by OpenTelemetry. That's great. We talked about why vendor neutrality there is awesome. Now vendors are starting to sort of see the value, customers and vendors are starting to see the value in the OpenTelemetry collector, and we're starting to get open and interoperable pipelines. We already talked about why that's awesome. Let's talk about that last box. So here are some of my favorite open source things for dealing with observability and telemetry data. So we have kind of this yellow area, which is like your Prometheus ecosystem based around PromQL. Very popular format, right? There's tons and tons of exporters for it. You probably already have a ton of stuff in Prometheus exposition format. There's also a ton of tools for you to use, right? There's Cortex and Thanos from the CNCF. There are proprietary but open source tools like Victoria Metrics and Mimir from Grafana. These are all great if you deal with time series. Sorry? Yes, they're all open source. But it's a vendor-backed open source, not a foundation open source. So it's a little different. Yeah. Yeah, the stars are the vendor, the like under foundation ones. But it's all great. Use all of it. We have Grafana. Everybody loves Grafana. Persis from the CNCF, right? For visualization, this works with PromQL. Then we have like the OpenSearch and Elasticsearch ecosystem, which uses the Lucene query language, which you've probably seen before because some vendors expose that directly when you're looking at your log search. And then I personally, as someone who works on ClickHouse, I'm a huge fan of SQL-based observability, which is starting to become more of a thing. There are some plugins for Postgres like TimescaleDB that make it appropriate for time series data. There's InfluxDB, which is not SQL-based, but kind of got grouped into that category. There's Apache Superset, which is a dashboarding tool that also supports SQL. So yeah, we have a lot of options.
We do.
Yeah.
So now keeping all that in mind.
We
Nope.
we did it again.
Oh, I'm so, damn it.
Stop taking my slides, Adriana.
Sorry. We need to start putting like money in a jar every time we do that.
So my vision for the future of what this could look like is like, what if our vendors did allow for us to get that data out again, right? What if once we put the data in storage, we could store it once, but use it for multiple things? Like now we're all kind of interested in like training our own models and having them fine-tuned on our specific data. Wouldn't it be cool if we could do that model training off of our telemetry without copying it? Wouldn't it be cool if the executives could always keep using the same tool for their dashboards and reports? And when we decide we want new analysis tools, it doesn't have to affect their workflows. And they don't have to tell us, no, we want the old tool. And then, yeah, of course, like us as operators, we get all the tools that we want, maybe more than one. Pretty cool.
Very cool. The possibilities are
poop.
endless. Yes, I'm switching slides now. Talk about why OTel is successful. And to explain that, we're going to draw your attention to this lovely XKCD comic where I feel like OTel is one of those cases where
it's the counterpoint to this. Yeah.
It did not happen. where you know, we had all the competing standards and we created the standard to squash all standards and it stuck.
It happened.
Holy cow. Right on. Score OTel.
For sure.
Yay. Also, OTel is the second highest velocity project of the CNCF. So
kind of makes sense, right? Like it touches all of us. So it makes sense that we might all have something to contribute back, right?
it does. So why is OTel successful? 3 things. Openness, cooperation, and stewardship. The OTel community ecosystem is honestly like one of the nicest open source communities I've worked with. My first foray into open source, like I've been in tech for over 25 years. My first open source contribution was in 2022. I was terrified to submit my first pull request. And the OTel folks, just like when they replied to my pull request, it was like really nice, thoughtful comments. So I'm like, okay, I'll keep submitting pull requests then because these people are actually nice. So that's a huge thing because if you're not assholes to the people making contributions, it means that more people will keep coming back. Hey, novel concept, right?
Yeah, it's amazing. And there's cooperation too, right? Like OTel is a collaboration of many competing vendors. I would consider Adriana a close friend now, but that all started when we were working at competing companies and met at an end user SIG meeting.
Yeah, and that's the thing. Everyone in the SIGs works for a competitor, but we're all friends. I do not view folks, my fellow maintainers in the OTel end user SIG as like, oh, they're a competitor, I'm not going to tell them anything. No, they're friends. We're working towards the same goal. And I think what's better than having like one organization coming up with a solution for something than having like 10 or more organizations working to solve the same problem and actually not being jerks about it and sharing that information and caring about what's going on. So that goes a huge way. Yeah, and then finally stewardship. CNCF keeps us in check, make sure we're not jerks to each other. And I think also, like I said, the open telemetry community by design also strives to work like that as well. They're very, very particular about ensuring that the vendor neutrality is enforced. I've had a case where I was writing a blog post and we were showing my co-writer and I were showing screenshots of different how telemetry looked like in our two respective vendor products for the vendors we work for, and the reviewer for the blog post said, we want to keep this vendor neutral, so we'd prefer that you not include screenshots of products from your companies and instead use an open source tool. So
Like
we settled
Jaeger.
on just doing screenshots for Jaeger for the traces, for example.
Yeah.
And that was super nice. They didn't approach it in a jerky way. It was really nice, thoughtful, and I'm like, yeah. And so I pay it forward whenever we encounter a situation of like, oh, this person isn't, living up to the vendor neutrality standard. You remind them gently. You don't be a jerk about it.
That's nice.
And so, how does this all benefit you?
Like, this isn't just empty platitudes, right? There are actual benefits. We talked about these. So the portability of the telemetry data means that you can change tools if you really want to, right? Like, I still think it's not all about that day where you change vendors, but it is certainly easier thanks to open telemetry. And you also get the interoperability. We talked about why this is awesome. And when you combine both of them, you get
choice, which is amazing. And so this allows us to
ask meaningful questions,
get useful answers, and take action. And by the way, shout out to Hazel for the awesome definition
thanks,
of
Hazel.
observability. I will keep using it over and over. And that's it. So here are some references and shameless self-promotions. I do have a link to Josh's LinkedIn post that started this. A link to my Medium blog post that was a response to his post. For anyone looking to learn more about observability with OpenTelemetry and likes videos, I have an O'Reilly video course on OTel and observability. I have a podcast, as I said. It's called Geeking Out Podcast. It has a capybara as the logo, and it was designed by my 17-year-old daughter who wants nothing to do with tech. She's going to be a nurse starting in the fall. And I've had really cool guests like Kelsey Hightower, Charity Majors, Liz Fong-Jones, most recently Scott Hanselman. And Josh has a podcast.
I was also on your podcast.
He was on my podcast recently. Yes, actually, there's a few
I'm not as cool as Scott Hanselman,
There's a few
but
people in here who have been on my podcast, which is really cool.
Hazel's been on my podcast, Unevenly Distributed, and yeah, we won't keep you guys from socializing anymore.
Yeah,
Thank you.
and if you're interested in the end user SIG, we like to share end user stories on OTel. If you have a cool end user story you want to share, hit me up. We connect end users with each other. It's really a place for us to learn and understand how people are using OTel out in the wild. Also, at KubeCon, we will have an OTel booth in the project pavilion on Tuesday only, Tuesday all day. Come say hello and show your love for OTel. And also, if you want to join any of the SIG meetings, we'll have some on-site SIG meetings and meeting tables near our booth. And for anyone who wants to join a SIG meeting, this is the SIG meeting schedule for on-site meetings. And that's it. Thank you very much. Go enjoy food and drinks.
All right, we have a couple minutes left for any questions. All right.
I thought there was a OTel podcast, or
I'm not. Is there a specific official one?
Yeah, so the OTel end user SIG runs a couple of podcasts. We have OTel Me, which is a Q&A where we get folks who are practitioners of OTel talking about how they use OTel out in the wild. And then we have OTel in Practice, which basically, if you're doing something cool in OTel, want to share how you're using OTel, it's a meetup style thing where it's basically like give a presentation about cool OTel thing you've discovered. So we welcome anyone who wants to sign up to do one of these. Please hit us up. Sorry? Oh yeah, that's right. We'll be at Maintainer Summit tomorrow talking more about the OTel and end user SIG and how we use that to foster OTel communities.
So how are you actively, or how does the OTel community actively drive more adoption of OTel and moving away from some of the more vendor-specific standards?
Well, I think, right, like we've laid out some of the reasons why end user companies are moving there. It's that, right, it's that interoperability. I kind of glossed over this, but I think that in observability, right, most solutions are going to give you like at best 98% coverage of the things that you're using. And that's not good enough in observability. You need 100%, especially if you're doing distributed tracing, right? Any gaps completely breaks the usefulness of the entire operation. So you need 100% coverage, and really the only way to get that is with open source tools.
Thank you again. All right, our next talk is going to be doing an update on Helm 3. Please come forward if you're that speaker.
Thank you very much. So I'm Evans, as you've heard. I'm a co-maintainer of Helm, and I also work for Replicated. I'm here to give a quick lightning talk of what's coming with Chat v3. Hope all of you are enjoying Rejekts so far. Good. So, what is in this? There you go. So last year in November, KubeCon Helm v4 was released. So Helm v4 introduced a bunch of nice things such as plugins, server-side apply support, and also case status for waiting for resources as they get deployed, and so lots of improvements were made. But still, we still didn't solve a majority of the issues that we see being asked for in our issues. So in Helm, if you go to the GitHub issues list, you'll get to see lots of requests. There are things that they would like to, things like ordering your Helm chart. So you have a chart, an umbrella chart, you have a bunch of dependencies as sub charts, and you'd like them to be ordered in a certain way. You want your database deployed just after your app. So things like that, or separate template engine, or passing passing values and having them formatted in a certain way. So things, such kind of things were hard to implement. Also git ignore, Helm ignore supporting sort of the git ignore format, which everyone uses. I don't know why we ever had Helm ignore in the first place, but there you go. Such things won't change, couldn't have changed without breaking charts that we have out there in the wild. So what we did is introduced charts v3. So as you can see, it's very simple, straightforward. You just need to switch the version label. And that's a deliberate change, so that it was made this way deliberately just to ensure that anyone who's authoring these charts is migrating their charts. So it's a deliberate change. It wouldn't be transparent. Now, with Helm, and also just want to mention Helm 4 is completely backward compatible with Chat v3. Chat v4 will come in, and they both can be used at the same time. So it's more of a coexist sort of strategy here. You can have your Chat v3 installed in the same cluster and have your Chat v4 still in the same cluster, and Helm will handle that seamlessly. So what to expect? Obviously, the community need, this is more of an outreach as well to the community to bring more ideas of things they would like with Chat v3. But some of the things, the hips that we have here are chat-defined plugins. So I've talked about the problem where you'd like to have your values file formatted in a certain way before Helm consumes it in its chart. So this is an example. And resource sequencing is also another thing. Resource sequencing is quite interesting because it's an ability of you to order how you'd like your resources to be deployed. Your charts on a chart level, or your resources within the same chart. You can annotate them. And git ignore is also another one. So those are the three hips that we have ongoing. There's work ongoing to implement this. Chat v3, it's being introduced through as an experiment right now, so it's experimental. You'll have a Helm experimental chat environment flag, which once you enable, then you get the capabilities in, and you can use that with commands such as Helm create, and you get access to internal packages as you're working with your chats. Once it gets GA, then those get removed. I'll show some examples of what we've done so far, or rather what's happening at the moment. So this is with the chat defined plugin. That's an example of how a chat would look like and how you define your, in this example here is now defining plugins for rendering. So here you have the YAML script, for example, if you want to have a YAML script as your renderer. Then here you have another example of, there you go, oops. I'll close that. There you go. Here's another example of your chat defined your, there you go, your subchat ordering, which works and how it looks like. You're free to try this out already. This is the progress of where we have the chat v3 enablement. We have feature plugin, help create the chat v3 implementation, partially implemented, but you can try it out today. We still need to implement a few more things. You can meet us at KubeCon. We will have a booth, and we'll have, if you'd like to talk more about where we are with this, please come speak to one of us. Thank you.
Evans. And now for something completely different.
A second.
You're already in the meeting?
I'm already in the meeting. So
Then you just got to present and you're in good shape.
okay, so just a second. Why is it not working? First.
Do you want to do mirroring instead of?
Okay, I do mirroring. Okay. So
I usually do the whole screen. Firstly, this one here, and then you pick the one you want. Yep, exactly. And then you just want to make sure your presentation is on that desk.
Why? I'm so sorry. That's, you see, AI is not going to take away our job.
And share. Microphone.
I'm so sorry. So let me close this one. Okay. So I want to talk quickly, and now the counter goes. I want to talk about the Ralph loop, okay? So how to Ralph loop is the question, or I would call it how to burn tokens with the Ralph loop. So again, there will be a lot of Simpsons stuff going on. So please, Disney, don't sue me. If anybody is related here with Disney, don't snitch on me, because this is the guy I can only afford, and he's probably using also ChatGPT. And yeah, that's not good. Okay, the Ralph loop. So how to autonomous AI loops. Okay, shortly to myself, Engindiri, there are some of my socials. You can find me on Twitter and so on. Nothing new. I checked for a plan B. I asked AI, I said, hey, what could be a good plan B if everything goes down and I get redundant? And he told me I have to become a trader. So if I come to your house and change your HVAC, that's probably I got made redundant by AI. The Ralph loop, it went crazy. It went completely viral. If you not heard anything about the Ralph loop, then you're definitely not scrolling much on social media, which is good maybe, but in this case, it went crazy. Everybody and my mother made a video, a blog post, and so on about the Ralph loop. So completely viral, how you wanted. Even I did 2 articles around this. So I created a SAS and then also a little bit verification with the Ralph loop. And it went so nice that even the creator of the Ralph loop reposted this one and mentioned Ralph can do the job of a DevOps engineer. Yay, that's nice. So what is the problem of the Ralph loop? AI babysitting. So what we talk about AI babysitting, yeah, long sessions. Again, you will see some points which are, because AI is so much changing, some of the points are not valid anymore, some points still are. So long sessions compact, critical details get completely lost when the compaction kicks in. We all know around 80% we come into the dump area. We should, the dump area, we should never go there. Context fills up silently and then we come into the compaction modus. Babysitting AI sessions, that's also something we have. I have a colleague at work who advertised the Warcraft alert. You know, you can hook into your AI system and then play Warcraft orc sounds like, yes, Captain, and so on, because they have a lot of windows to maintain now, and sometimes they forgot completely the window. Same for me. I use CMAX. CMAX has a notification system, but yeah, checking all on my windows to see what's going on, AI babysitting. And then a lot of quantity with quality. We have a lot of AI-generated PRs, which gets rejected. Peter Steinberger from OpenClaw is really hardcore. If you come with this sloppy PRs, he's going to block you. So there are different ways to do this. And this is the most annoying thing. Agents think you are done, but actually are not. The systems, even the newer models, they are so completely eager to finish the task. They fake shit like I did back in the days when I had to do testing and all the stuff. So it's really skips testing and also changes the logic to just fulfill your need. So, okay, sounds familiar? Should be. Short words for the creator. He's a really interesting person. Please look him up. Geoffrey Huntley. He's an Australian dude. And yeah, crazy work he's doing. And he also created a compiler called Cursed for Gen Z people. And then he discovered, which maybe in retrospective now sounds like, yeah, that's obvious, but he discovered that running things in a loop is very good because it creates all the time a fresh context, and that means very good output. Okay, why Ralph Wiggum? Yeah, Ralph, because it's the Simpsons character. He's a little bit stubborn. He's doing all the time the things, and that makes him very persistent. And this is more interestingly, Ralph is a slang word from the 80s. I checked this with some American people. Yes, Ralph means to vomit. So the loop, Ralph's code until the test passed, yikes. And yeah, in the purest form, Ralph is a bash loop. Okay, theory. We all know this now. This is even more true than when I wrote this. Generating code is now cheap. What is hard to ensure that Ralph or that what we create is the right thing. And that's what he said. So they use, the Ralph loop use heavily Git as memory, one task per iteration, fresh context per loop, back pressure, very important to know what we are doing, back pressuring the system via tests, via checks, linting, everything. You should be part of your harness in your hooks that you tell the system whenever you generated a piece of code, let's go and challenge the system. And then the human in the loop is only here to do the supervising and don't micromanage. I'm getting close. Okay. Then I go to the 3 phases of Ralph, and that's enough. Phase 1, define the specification. Phase 2, the plan mode. So you do your implementation, and then you head over to the build mode where you feed the stuff in. So it's really like this, the Ralph loop. While do cat your prompt MD and then say cloud code. To work on it, cloud code -p, for example, and then you keep on iterating through every piece of your task. And that's it. There's an ecosystem. Check it out. Thank you.
little closer. All right. Our next presentation is by Herdick. Then we'll have Lucy Sweet, and after that we will have Hippie. Here you go.
Hello, hi. So I'm talking about today about LLM and how it can be a resource hog. So I presented this talk last week at Scale.
I don't mean to interrupt you, but you need to share your screen with your browser.
Oh, okay.
Go back to your browser. That's the button. Yep. Select that. Select your screen. The thing that you're sharing. Oh, you have a permissions thing, perhaps. Just hit the entire screen. It's easiest. Yep. All right. Now you're good to go. Right? Okay. Good to go. Thank you.
So it was a 80 slide talk an hour. So I've reduced it to 5 minutes. So hi, I'm Ritik. I am a CNCF ambassador and I work at a platform advocate at vCluster. So generally, whenever we talk about LLMs, like local LLMs or LLMs in general, there are a lot of problems which considers as a resource hog. Models take sometimes long. There is inconsistent performance, GPUs, and throughput is slow. So this is how a general LLM architecture is. You have your client, which is us, and there is a response. In between, there are a couple of layers. There is a router, batcher, caching happens, GPUs happen. So there is a lot of moving parts in it. So whenever we want to diagnose why LLM is slow, we can break down it into 3 parts. One is the KV cache part, one is the GPU part, and another is the observability part. So we will go a bit in each. So KV cache is generally when, in simple terms, you don't want to read an entire book every time you're reading a sentence. You want to cache it so that next time when there is a similar query, it takes lesser time and you can serve from cache. So you can optimize cache with VLLM with page attentions and continuous batching. LLMD is there where you can have cache-aware routing, which increase the time to the first token. And then there are options like tiered caches and all those things. Next is the GPU solution. So generally the problem right now is like GPU is not always fully utilized. And even if you increase the number of GPU, if you see the P99 for time to first tokens, increasing 4 to 8 GPUs doesn't changes anything. And the streaming multiprocessor as well, variation in per GPU resources over per GPU is very high. So you're not actually helping if you increase the number of GPUs. So here, a couple of things come into the picture. You can batch your requests together so that you get better performance. And then there are other options like MIG time sharing, MPS, time slicing, and Kai scheduler, which focuses on different areas of serving. So whenever you're using sharing so that your inference or training workloads can be served across a single GPU, you also need tenancy and CRD controls. So here vCluster-like solutions come into the picture where you can have different tenants on a single cluster. So you can share an entire GPU node and set of nodes across different tenants. And then the last part is the observability solution, which we always look down to. The reason is because whenever we are training RNNs like this, sometimes a GPU drops humongously in between the training phases, and this is because of data loading bottlenecks and others. And sometimes while you are using GPUs, some GPUs drop because you are not, the goal is to keep observing all those things, not just observe for one sentence. So that can be a data distribution bug or an imbalanced workload, which causes all those issues. Overall, the goal of this talk is like you can cache smarter, scale better, and see everything if you want to use better inference for GPUs on bare metal. And I have a longer version of this talk. If you want to see, I will send it to you. And this is my socials if you want to connect. Thank you so much.
Perfect. Thank you. Lucy, you're up. Yep.
See if this works. Yeah, I'm sharing my screen. Is that then visible on there?
It will be. I mean, the share
Connect
isn't
to
on there.
external display. Mirror. This is going to be. This is professional. Don't worry, guys. Present on the connection display.
Live mobile.
Wait, that's the wrong slide. We've gone way too far. Present on the connected display. Yes, I'm doing this on the phone. Don't wait. That's not going to work either. I'm just going to do it like this. How about that? I'm just going to do it like this. Okay, yes, hello. My name's Lucy. I'm a staff engineer at Uber and a maintainer on Kubernetes. This talk was actually presented also in November. Back then, I swear it wasn't just one of 100 LLM talks, I promise. But anyway, I was on the way here to KubeCon this year. It took me about a day to get here. I had to drive to the nearest regional airport because I live in the middle of nowhere in Denmark to find a scheduled flight. That flight took a good 1 hour. There was a crying baby on it. And I thought, honestly, this sucks. Why can't I just have my own plane? Why can't I have a private jet? So I went on ExoJet and I found out very quickly why I can't do that. Unfortunately, I cannot justify a $13,000 1-hour flight. But that got me thinking, there is this interesting behavior in our industry right now, this interesting change in market dynamics. So I thought maybe I could leverage this through Kubernetes somehow. So in a moment of genius, I have this idea. If we look at Kubernetes today, we have here kubeproxy, kubelet, etcd, whatever, you'll notice. There's a few problems with this. The first is there's no enterprise licensing. And that means no one can find an excuse to give Kubernetes billions of dollars. There are also 0 AI features by default. And these things combined means there is no VC interest in Kubernetes. So this is a serious problem. I can't deal with the enterprise licensing part, but maybe we can deal with the second part. So how do we fix? Yeah. Hello? Oh, okay. So maybe we can do the second part. Maybe what if we replaced kubeproxy with an LLM? Or what if we replaced kubecontroller with an LLM and etcd with an LLM? And let's just replace the whole thing with an LLM. So what I then did is I asked my engineering team, can I just replace Kubernetes with an LLM? And it came back with, yes, of course you can. And so I did a bit of a comparing. So Kubernetes, 74 million lines of code, 1,800 open issues, and months and years to add a new feature by hundreds of maintainers. My code is about 11 lines of system prompt. So, you know, a lot easier to maintain. This is an actual thing. I put it on a domain. This website is entirely vibe coded because of course it is. Now we're going to do the demo. Let's see if this works. So first off, welcome to my phone. We're going to open up a terminal. Perfect. Wow, I didn't. Okay, let's just do this for the demo. Yeah, let's just do it this way for the demo. So we are connected to the Kubernetes cluster powered by an LLM here. So if I do, for example, kubectl version, it goes off to an LLM. There's no real API server. It's all fake. And we get a reply. It looks like a real Kubernetes server. We're running on Kubernetes version 1.48, which is very impressive given we only just released 1.35 a few months ago. So then let's then try and create a deployment. You can see I'm not very fast when I'm typing with one finger, but we'll try Kubernetes kubectl create deployment -- image equals nginx. Don't worry, that's all part of the engineering process going Oh, and I need to put a name. Yes, sorry, I didn't do that. Let me go back and do that part. I'm an expert at this. Don't worry. Kubernetes is safe in my hands. Okay, and now this is going to go off to an LM that's going to think about it, and maybe in a bit it will say it created this deployment. This is going to take a bit. The latency on this, you do have to sacrifice about a 7,000% latency increase, but in return, you get to create features by just prompting LM. While we're waiting, any questions so far? Why? Yes, thank you. This is crowdfunding the responses. Yes, why? Because I can. Okay, cool. Our deployment was created. So now if we look for the pods from it, so let's do kubectl get pods. God damn it. Yeah, maybe I should have got a laptop for this. What do you all think? We're a startup, guys. It's VC funding. It's a bit tight. We are not YC funded, not yet. Okay, so now kubectl is going to be looking for pods. Well, it says it is. This is just a large language model pretending to be an API server. And sure enough, we get our pods. It's been running for over 2 years, which is another feature of this amazing system. You know, we just preempt what you need and create it before you even want it. It's like the teleports behind you meme. So then if I, what was it? If I get this pod here, so then I'll just do -o YAML, And now the server is going to tell me about this pod, which definitely exists and definitely isn't being hallucinated into existence. I'm getting the get off the stage signal. Okay, here we are. And see, we have a full pod. It's fully running. The UID is 234567890. But you know, that's just the artifact of it. Cool. So very impressive demo. I need to wrap up very quickly. So blah 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 blah. You've all seen all of this so far. Okay, yes. So this is better than K8. Scheduling is now confidence driven. Pods are placed where they feel they belong. State is an implementation detail. Durability, now it's customizable. It can go from 0 to 100%, anywhere in between. And scale, AWS and GCP spent millions of dollars being able to run 80,000 node or 100,000 node clusters. I can do infinite nodes because my ALM can just claim it's doing that. If you have questions, too bad, it's a lightning talk. The big QR code takes you to the web page where you can actually interact with this thing. And the small one brings you to a Stripe link where you can buy 7% equity in this startup at $500,000, which is a standard Y Combinator deal. That is a real Stripe link. It actually works. And I don't know how Stripe approved that. That's it.
Thank you, Lucy. Next up is Hippie. You can have this one too. Merry Christmas.
Yes, I'm fine.
You got your what you want to present on?
I can't find my stick, but we'll try something else.
Okay. Well, do you want to present anything?
Yeah.
Do you want me to run for it?
I can't find it. Okay.
So yeah, can I have to have
All right. Our last lightning talk is a surprise by Hippie.
Oh, you're good. Thank you very much. Hi. Thank you, Duffy. My name is Hippie Hacker, and I wear a hat made by my son. I call it the magical hat of many perspectacles, because sometimes I have to take off these and put on. My wife's color is turquoise, so I don't have yours today. I don't know where it went, but I got these, and this doesn't go AI thing. It just goes local. So they got some words, you say. You got some words that you say, and it's, ooh, it sounds fantastic in here. Hi, hey, Meta video. Hey, Meta video. Hey, Meta video. Anyway, we'll wait for it to come online. One of the things that I like to do is I like to connect humans. Oop, that's my right ear. So I'm going to put this one on my left. And I'm flexible still, sort of. It's my right ear? My right ear, yes. So I get confused on my left and my right. So I have red on my right, blue on my left, because I have a memory problem. I can't remember your name. So if I come up to you and I say, do I come here often? I am being serious because I don't remember. And so I've had to create memory semantics and devices for me to remember things. And so one thing I had to remember is that there's an I in front of a lot of things. And I things are all about the human holding them versus others. And in my pocket here, I have something some of you may recognize. This is a very small device. It's called an iPod. It predates the Kubernetes things by a bit. But I like to do things with other people. So I put I in front of it because that means you're an I and I'm an I. If we spend time together, then that makes things more interesting. I have been working on some prototypes to connect people. One of them is being able to telephone, right? You can talk and you can see someone and you put your voice somewhere else and you can hear their voice. Another is television, where you can see what they're seeing. Hey, Meta video. Anyway, so one of the things that we can do with that is be able to be in another place, telepresence, if you will. But the one thing that we lack is the ability for our hands to teletype. Used to, when you would do teletype, you'd put some dits and dots on some lines and go across the United States or other countries over the wire, and then eventually via Marconi wireless, and you could put your words in another place. And then we started using touch. So you could teletouch. Teletouch is a very fascinating concept where you can touch and have it come out to the side. But in order for that to happen, you have to have magic sticks. This is a toko-toko. In Maori culture, I have learned that if you get to be an old man and you come in and you walk with a stick, they go, oh, you wouldn't take a stick from an old man, would you? But if you go into Rohan and you get through the doors, they go, oh my gosh, that's a wizard. So one of the things that I've tried to do is create some magic sticks. And one of the things I found from a friend of mine that I just met today for the first time, I flew him in from Warsaw. He makes these things called input sticks. You'll see it over here. And I'll need some help here in a little bit. What I'm going to do is I'm going to teletype and teletouch via this input stick onto the phone I'm holding here, because as you get older, you can't see and you can't help. So my grandmother, when I want to help her, how do I help her? She's on a device and I can't see what she's doing. I can't touch the screen. But if I were to plug in a USB keyboard and a USB mouse to her phone or her iPad or her computer, I could come over and it would work. Hey, meta video. There we go. So this will be available a little bit later. One of the things that the teletouch and teletype would allow us to do is to be able to help our humans all over the world. So, and the timing is ridiculous. We lost power here. So we'll do other storytelling things. So when you lose power on an II device, I'm going to set the toko-toko down. What if this universal bus that we use to connect this all is too small? What if we had, like in Jaws, we're going to need a bigger bus? And so the universal serial bus that connects us all, what if you could transport it from one place to the next? These are pixels. They're phones from Google. And if you turn them off and turn them on again and you connect them to a web browser, there's a thing called Web USB. And you can actually flash this phone from a website in your neighborhood. And what if the kids in your neighborhood were able to get a device and when they turn it on and they flash this, oh, I can help people? Who could I help? Yep, and so I want the kids to be in any nation or neighborhood to be able to reboot a phone. To reboot the neighborhood and be able to help the people in their neighborhood so we can reboot education and other things. So my name is Hippie Hacker, and I'm glad to be a part of this community. And come say hi. Ask me what's in my magic hat. Thank you very much. Hey, Meta, stop.
Thank you all for being here. One of the things I like to do here toward the end is just to get a quick selfie. So I'm going to take a selfie with all of us real quick, and then I'm going to turn it over for closing remarks. So let's just get that done real quick. Everybody try and get in the frame. Oh, here we go. Everybody in there as far as I can get. 3, 2, 1. Thank you. All right, now I'll turn it over for closing remarks.
Thank you. This is bright. Hello again. Thank you all for being here. We had a wonderful day with all of you. Thank you for joining us, making this event a wonderful day. Thank you for all our speakers today, for all the rejected talks that we had here. This made this event very special. And I loved seeing the energy. I loved seeing all of you connecting, being out for lunch, talking during the breaks. Big thank you, and I have to read that now, also to the organizers and the entire team making this event possible. So we had only 8 weeks, right? So we had only 8 weeks, and I'm really proud that this all worked, yeah, quite
quite effortless today. And I have to read some names now, I'm sorry. So thank you to Chris, Carlos, Alessandro, Katalin, Pavel, Mohammed, Shoham, Prithvi, Luca, Rolf, Hannes, Immer, Jos, Colin, Luke, Mathieu, Sriram, Orlin, and I hope I didn't forget anyone. And last but not least, our steering committee, that was Laura, Lexi, and Marcus. You are such a great help in all of this. Would not have been possible without you. And also, of course, all the volunteers that helped today, making everything easygoing, from registration, the talks, microphone setup, all the questions that you answered. Thank you so much for being part of this and making this happen. And final thank you, and then I'm done, to the sponsors again, obviously, to ProsperOps, Idera, and Miro for this wonderful location. And obviously to Microsoft, Isovalent, Artem, and FikaWorks. Thank you all for having us here and making us a great day. Handing over to Luca now.
We went a long way. We started this morning, and I hope you had half of the fun that I had today. I have incredible conversation with good friends, people from all over the world, and I don't know if you realize how diverse and collaborative is this community. We started just a few months ago in December, but when we were thinking, yes, we need rejects happening, and we made it happen with the effort of all these volunteers, and this is a community-driven event right now. We were thinking with a friend with a couple of friends in one event, no, we need to make it happen because people are expecting reject. I hope you bumping in good friends, and with a good start, this is just paving the way for a fantastic KubeCon 2026. In this world where AI seems to be ubiquitous and do crazy things, we value reality and connect with people. I hope this will be the stage for fantastic new idea, disruptive new innovation. And now we pass the virtual torch to Salt Lake City in America. So I hope that they can organize a great rejects events. And without further ado, we wish a great evening. And there is a lot of locals that can guide to, I don't know, events happening in town. And one more thing, I know that there are events and community happening. I know that tomorrow there will be Cube Train from people traveling from all over Europe by train in a sustainable way. And we have Andrea, one of organizer between us. Then over there. So if you, thank you for organizing this initiative. We need more European things. Another standout is for Cube karaoke. So if on Tuesday you are fancy having great karaoke or just connecting with other people, where is Leon? Leon, she's over there. She's leading this fantastic initiative. Another thing that I want to stand out is Katalin is the ambassador of Romania Cloud Native Day. So if you want to connect, have fun, or maybe be a speaker to this initiative, he's the go-to guy. And if somebody else has a great community initiative, this is the moment to come along. Happy to promote your event. I know that next event, there are a lot of side event, beside event, even if you didn't make it to the KubeCon, I know budget sometimes is tough, come along, and there are so many events in Amsterdam. I created like a blog post, and there are more than 40 different events. So I start losing count. And what is next?
And some drinks now in the next 30 minutes. So feel free to grab a drink and start talking again. So enjoy, have fun. Thank you all for being here.
Thank you.